and represents in several international forums. The Institute is privileged to welcome you all at this occasion. We have honorable presence of our dignitaries today. To commence this occasion, I would now request our Honorable Chief Guest Shri S.B. Vasava and our Honorable Guest of Honor Shri G.J. Joshi to please come forward for lamp lighting, and I request all the dignitaries to please join the lamp lighting ceremony.
IIT Bombay. He is specialized in payment engineering, including recycling, stabilization, and innovative technologies in construction of road payment, as well as the maintenance and preservation of the payment. I also welcome Dr. Sunil Basarkar, Head of the Geotechnical Engineer, for Afcon Infrastructure Limited, Mumbai. He has published more than 60 papers in national and international journals. I also welcome Sri Ashish Pathak, former head of the Ultratech Cement Limited, who has 32 years of experience in delivering diverse industries and technology. He will share knowledge on white topping technology. I also welcome Sri Dhruvang from the KV Tech, Harsh Patel from the KV Tech, who will make presentation on the building automation sustainable development. I also welcome H.U. Kalyani sir. He is a past chairman of the IEI as well as the chief engineer of the irrigation department, and yesterday I come to know he is the chairman of the water management forum. So claps for him. Let me introduce what is the IEI. The IEI established in 1920. IEI is the largest disciplinary professional body that encompasses 15 different disciplinary engineering disciplines. It has 8 lakhs membership. IEI is incorporated by Royal Chapter, and it provides a vast area of the technical professional and the support services to the government and industries, academia and engineering fraternity, operating from the 125 centers across the country. The institution has established R&D centers at various locations in the country and also provides grant in aid to its member who wants to research and develop a engineering subject as well as its skill. As stated earlier, the engineering are crucial to address the risks of climate change and to ensure the sustainable development. It is essential to design and develop resilient infrastructure for the sustainable of the society, economy and environment of the earth. Again, I heartily welcome all of you who is presenting over here for the success of the seminar. Extremely important seminar. Thank you to all.
Thank you, sir, for your welcoming words. We take this opportunity to welcome our honorable dignitaries on the dais. We have honorable presence of our chief guest, Shri S.B. Vasava, Secretary R&D Department, Government of Gujarat and Council Member, Institute of Engineers India. I request Shri P.M. Chaudhary, Chairman, Institute of Engineers India, Gujarat State Centre, to welcome our honorable chief guest at this occasion. I request Engineer D.O. Nakrani, Honorary Secretary, Institute of Engineers India, Gujarat State Centre, to welcome our Honorable Guest of Honour, Dr. G.J. Joshi, Head of Department, Civil Engineering, SPNIT, Surat. I request Shri P.M. Chaudhary to welcome our Honorable Guest, Chairman, Governor, Board of Water Management Forum, Shri H.U. Kalyani. I request Engineer Chirag Patel, Committee Member, Institute of Engineers India, Gujarat State Centre, to welcome Professor Dharamvir Singh, Associate Professor at Department of Civil Engineering, Indian Institute of Technology, Mumbai. I request Engineer D.O. Nakrani to welcome Dr. Sunil Basarkar, General Manager, Afcons Infra Limited, Mumbai. I also request Nakrani ji to welcome Shri P.M. Chaudhary, Chairman, Institute of Engineers India, Gujarat State Centre. And I request Engineer Hemant Sudha, Committee Member, to welcome Engineer V.M. Mehta, Joint Director, Staff Training College. And I also request Engineer Hemant Sudha to welcome Mr. Ashish Pathak from Ultratech. And I request Engineer Chirag Patel, Committee Member, IEI, to welcome Shri Harsh Patel from Kevitech. At this occasion, we also welcome Shri Ashok Patel, Chief Engineer, and Shri J.B. Patel, Retired Chief Engineer. We request committee members to welcome the dignitaries. Let's all have a big round of applause for all our honorable dignitaries at this occasion. Thank you and welcome one and all. As we know, today we have gathered here on the occasion of World Engineering Day for Sustainable World. At this occasion, we have honorable presence of our We extend a special welcome to Siani Sahib and Bakharia Sahib at this occasion. So once again, Institute of Engineers India welcomes you all. We have honorable presence of our guest of honor today, Dr. G.J. Joshi. He is working as a professor of transportation engineering and planning and head of Department of Civil Engineering at SPNIT Surat, having more than 30 years of experience in teaching, research and consultancy assignments in field of urban transport, highway designing and road safety. He has guided more than 60 MTech dissertations and 15 PhDs and has published more than 150 research papers in reputed national and international conferences. He is a coordinator of the State Technical Agency, Pradhan Mantri Gram Sadak Yojana for the state of Gujarat. We take this privilege to invite Honorable Dr. G.J. Joshi. So we are privileged to have Honorable Shri G.J. Joshi at this occasion, but due to urgency or some urgent work, our Honorable Chief Guest has to leave, and so we would like to invite our Honorable Chief Guest Shri Vasawa ji for the address. As we all know, he is a guest of the seminar today, Secretary in Road and Building Department, Government of Gujarat. He is also President of Indian Road Congress at national level, Chairman of Gujarat State Centre. He was Vice President of Indian Road Congress and Vice President of Institute of Engineers. So today we are privileged to get enlightened by his immense knowledge and vast experience. Over to you, sir.
Morning to everyone. I first sincerely apologize for coming delay because of there was one webinar which was being addressed by Honorable PM. It was specifically on infrastructure in country in 2047. So I was required to attend that webinar, so I had become very delayed. I again welcome all of engineers on the World Engineering Day. My fellow on the dais, Professor Joshi, Professor Ranbir Singh, Mr. Sunilji, my colleagues in the institution and government, Sri PM Kalyani, Sri Nakrani ji, all my senior chief engineers sitting, from whom we had also run a lot of engineering, Sri Siani sir, J.B. Patel as well, and all the engineers gathered here. Today the theme of the seminar is the sustainable engineering for the resilient world. This is a very, I would say, it's a need of time that whatever infrastructure we are creating should be resilient. Not only in terms of the engineering, but in terms of nature and environment. Because whenever we design something, I normally found we look only from our engineering perspective. Quite a time we miss the what is the habits of the user, or what is it is likely to subject in over lifespan of the structure. So with the new technologies and the more and more mathematical models and tools available with us for analysis and forecasting lot many things, this is a need of time. Even in today, Prime Minister also talks about the infrastructure not only catering present need, but say coming 20, 30 or 50 years. He specifically mentioned the development of Kutch post-earthquake, and I think CNSF was the one of the stakeholder in ADB funded road project. So he was specifically mentioned how he has, that what is the vision with which engineers or rather systems would work so that it cater all the needs. And again, resilient has become now quite a essential word, or specifically for encountering in design, because with the climate change and not many things, there has been catastrophe of 20 or 30 inch in 24 hours, and there has been some dry spell, there has been some heavy snow falling in the mountain region. So the theme and need has been, I would say, coincided today in this thing, and organizer has quite smartly played that way. So I wish all the success to them in this seminar. I am sure all will gather something and they will use it in their field, respective field, be it site engineering or design. So again, I congratulate the organizers and wish all the success to seminar. And I'll take a leave because I had got some another things. Thanks very much.
Thank you, sir, for your inspirational thoughts. I would like to request Shri P.M. Chaudhary to present a memento to our Honorable Chief Guest at this occasion. Sir, thank you so much for your valuable time. And as a mark of remembrance, a memento for our Honorable Chief Guest from IEI. Thank you. We shall now request Dr. D. Joshi, Professor and Head of Department Civil Engineering, SPNIT, Surat, to address all of us.
Thank you. At the outset, I extend my greetings on this important day, which signifies the role we play as engineers. I was just thinking how we can describe our role connecting with our belief systems. So I could immediately make out that we play a role as creators of infrastructure, we play a role of maintenance of infrastructure, and eventually we also play a role of destruction of the nature as a whole. That means we are playing role of three devs, Brahma, Vishnu and Mahesh. But now, since the theme is related to resilient infrastructure and climate change, these are the big words and buzzwords we have never heard in last century. These words are heard in this century, but it is very important now that we take it very seriously. Before we come to the title, it is necessary to understand the context and historical perspective of this important theme of sustainable development. If we look at the development patterns, globally if you see, there is something called global north and global south, and we fall under global south. There is stark disparity in terms of industrial activities, infrastructure, quality of life and per capita income in global south and global north. If you look at the our country, we have per capita average income of around $2,100 US, whereas the highest income per capita is $63,000 US per capita. So and average income is 25,000. So we are in the rising limb of the economic development, whereas those countries have crossed that limb, rather reached the peak, And they are, again, if you look at, try to relate the GDP growth or per capita income with impact on the sustainable development parameters, then they are able to reduce it. But on the other side, because the kind of concerns which are raising today, it has roots in how the global warming is happening. And one of the reasons for global warming is CO2 emissions, greenhouse gas emissions. So if you look at the world map of carbon footprint, we call it as metric tons of CO2 greenhouse gas emissions per capita per year, the global north has more than 7 carbon footprint, whereas global south has less than 3 carbon footprint. But if you see the economic condition wise, this is by topsy-turvy. And that topsy-turvy situation has arisen out of a period of 100 years of industrial revolution globally. Now the problem then, question comes to our mind, when we have not caused this damage, why we are so much concerned about it? The question comes there. The answer is, we are geographically separated by political boundaries, but the nature is not separated. So what happens somewhere else has impact everywhere. And therefore, as one Gujarati adage comes to my mind, kare koi bare koi, that sort of thing. That is what is happening. We have another adage also, khare khode de pade, kharo khode de pade, but it is not applicable here. Now somebody else has exploited the nature beyond its limit of resilience, and now everybody is facing. There is a gap of around 50 to 100 years so far as achieving the average world income between the global north and global south is concerned. And when you have to raise the average per capita income, naturally you have to give boost to the industrial activities. And when you give the boost to industrial activities, naturally, unless we go for innovative technologies, we are going to harm the nature at both the ends, in terms of exploitation of the resources, and at the other end, emissions of the harmful gases and pollutants in the nature. So that is the crucial issue which we are facing today. The efforts in this direction to address the climate change, there are two terms they are using: climate change mitigation and climate change adaptation. And mitigation relates to how you can reduce the adverse impact of developmental activities on the climate change, and adaptation talks about how we can adapt the way we plan, the way we design, the way we construct, the way we preserve, and the way we maintain our infrastructure, so that it will have least impact on the climate variables. The effort started somewhere in 1988, and those efforts were under the auspices of United Nations. They call it as protection of global climate for present and future generations of mankind. It started in 1988, and there were a series of consultations at government level. There were many technical and scientific organizations. Few of them you must be knowing about Conference of Parties (COP). Every year they meet, and there is some very important another organization of technocrats and scientists called Intergovernment Panel on Climate Change. So if we refer to the IPCC reports, they have put up a target, because whatever we do, the way we do, if it is business as usual, then it is going to be a very disastrous situation. The target set by IPCC, and it is accepted by United Nations, is that the rise in the average temperature of the globe should be limited to 1.5 degrees Celsius by 2030, compared to the average temperature of the previous century. Now in these 23 years of this century, we have already witnessed the rise of around 1.15 degrees Celsius in the global average temperature. So very narrow margin of 0.35 degrees Celsius is left with us, and that we have to achieve within next 7 years. In addition to that, we have also to reduce the carbon emissions, CO2 emissions, by 43% by 2030. If we do this, then only we will be able to mitigate the further deteriorating effect of the climate change. Otherwise, it will be the point of no return. And therefore, they are also shouting in all the conventions, conferences, that this is the last chance to save the earth, last chance to save the earth. So therefore, it's a perspective. India, of course, is part of the signatory of all the conventions of United Nations, and therefore it becomes incumbent upon us that we question ourselves, the way we have developed our infrastructure, can we continue the same way under the given circumstances? The answer is clear that no. Because the issue comes where from the electricity comes. comes from 85% of our installed capacity is thermal power plant. So it is also a major contributor to CO2 emissions. So it starts from the root. The electricity production itself has to be changed from conventional to non-conventional kind of things. Second is what kind of transport infrastructure we are developing, and whether we are adopting a kind of the concept that there is no waste generated and there is no waste remaining unutilized. Even if we generate the waste, it should be utilized. And that is where the concept of circular economy is coming. I think many of you might have heard about it. So that is the second component. Third important component which we have to adopt is whether the way we are moving our people and goods in our country, whether it is sustainable? Absolutely not. At the time of independence, around 85% of the passenger and goods were transported by railways. And now the situation is topsy-turvy. Around 70% is moved by passenger and goods. And this situation is leading to higher cost of logistics. You might have heard about it. Internationally, 8% is the cost of logistics. Now we are spending 14% on movement because the rail mode is around 6 to 7 times costlier than the road mode. Right? So therefore, there also we have to do a kind of a correction in intermodal combinations of the way we move the people and goods. Then comes what kind of fuel we are using. They are talking about use of the biofuels. Right? So there are first generation, second generation, third generation biofuels. How far we are able to adopt this. Then next comes what about the way people make the choices related to movement of their own and how we operate our transport infrastructure. That is where the role of intelligent transportation system comes into picture. So under this situation, we have certain pertinent questions to answer. The policymakers, the executors, and as well as the planners, everybody has to answer. Because typically if we see, the first question comes, whether the standards we follow, generally follow IS standards and IRC standards, whether our standards are modified, revised to handle the impact of the climate in the infrastructure we create. The answer is, I am sorry to say, the answer is no, we have not. We are late by around 2 decades in handling this. That is number one. Second question comes, whether we have enough enthusiasm, energy and activism to adopt the standards, if not available in our country, available elsewhere. Because if you look at, Europe has developed the climate resilient standards in 90s, whereas still we are struggling what kind of standards we should adopt. So that is the second question. And third, and the big question is, whether the engineers who have to handle the infrastructure, right from planning to maintenance, are they confident enough to adopt these new standards? That is the third question, and that relates to the way the government system works, a kind of inertia which we generally find in adopting the new technologies in the government system. So these are the 3 pertinent questions we need to answer, and I'm sure that the today's keynote speakers, Professor Dharamveer Singh and Dr. Sunil, will be able to give some highlight into what way we should construct, plan and design our infrastructure so that we can reduce the impact of those developmental activities on the nature. Remember, well, we are talking about the resilience of the world. It has 2 dimensions. Resilience of the world means resilience of the infrastructure we create and resilience of the nature itself. We have tested the resilience of the nature for last 3 decades, 4 decades, once we started economic liberalization. And nature is now showing the signs of non-resilience. And one example I will tell and then I conclude. 2 years before, we had gone to district of Kutch in Gujarat. We are state technical agency for PMGSY, and from GSRRD we got a call that Kutch has proposed around 72 bridges on rural roads. People will laugh, why you need bridge on rural roads? High level structures. Then they specifically asked us to visit all those locations or roads where bridges are proposed. And me and my colleague Dr. Srinivas, we visited because district is too large. So I went to western part, he went to eastern part. And by moving on to the roads and interacting with the local engineers and local people, we found that the rainfall pattern has drastically changed. Before 2017, average rainfall in Kutch was 8 inch per year, average rainfall. After 2017, it has gone to 40 inch. And typically on rural road, because rivers are also not developed, they are shallow. and therefore they generally construct this, kind of a deep, flushed causeway. They call it as papadi. In Kutch they call it as papadi. So those sort of structures they had constructed, and when the rainfall before 2017, rainfall was very scant. So the interruption would be only for 3-4 hours, and it would satisfy our all-weather road condition requirement of PMGSY. So there were no issues. But after 2017, they have found there are flash floods, heavy floods, and interconnectivity gets disturbed for days together, and therefore they needs to be upgraded in form of the high-level bridges structures. And it has, therefore, this is what that means. You are adding additional cost in creating this infrastructure, and when you use additional infrastructure materials, then you are again causing some kind of damage to the nature. It has lot of impact. So therefore, the issue is that adaptation is definitely a necessity, but more important is how we mitigate. Because what we do today is not going to bear fruit today. It is going to bear fruit after 2 years, 2 decades or 3 decades. So the generation of the eminent chief engineers who have completed the job, they are not going to face any adverse impact. But the young generation, you are going to face the adverse impact, and ultimately if you see in totality, the infrastructure we create is going to be so costly that overall net gain in the GDP growth will be reduced because of the additional cost we have to incur. So I think the problem is too big, the efforts are too meager, and therefore this can be a very important beginning for all of us, for the state of Gujarat, to contribute to contain the impact of developmental activities on climate changes, and also to adapt, to make the infrastructure resilient to the ill effects of the climate changes. Thank you all, and I once again thank PM Chaudhary ji for inviting me at this August gathering. Thank you.
Thank you, Dr. Joshi, for awakening and enlightening us on the need in engineering in current scenario, and for sharing your valuable thoughts. I request Engineer D.O. Nakrani to present a memento to our honorable guest of honor today. Charkha. Thank you so much. May I now request Honorable Shri H.U. Kalyani, Chairman, Governor, Board of Water Management and Forum, to address all of us at this occasion.
Very good morning to all of you. Dignitaries on the dais and off the dais, ladies and gentlemen. Straight away I wish you the happy World Engineering Day and purposeful talk today. As Mr. Dr. G.J. Joshi had already set the tone for today's program, and without taking much of time, as we have to hear the keynote speaker, Mr. Naramveer Singh and Mr. Sunil Bhaskarji. So I simply say the thanks to the organizers and congratulations to the organizers, and I wish that this talk will be very useful to all the engineers. Thank you very much.
Thank you, sir, for your inspiration. May I request Shri PM Chaudhary to present a memento to Honorable Shri H.U. Kalyani, sir. Thank you so much. We shall now move forward for the presentation, the technical presentations today. We have honorable presence of Professor Dharamveer Singh from Indian Institute of Technology, Mumbai. He is an associate professor at Department of Civil Engineering at IIT Mumbai. Professor Singh has been a faculty member at IIT Mumbai since 2012. And Professor Singh's field of specialization is in pavement engineering, focusing on recycling stabilization, new and innovative technology for road construction, pavement design and maintenance, and preservations of pavements, forensic investigations. Today we are going to get enlightened by him on the topic technologies for construction of sustainable and resilient pavement infrastructure. I welcome you, sir, for your presentation, and I'll request all the dignitaries to please take their seat in the auditorium, and we shall begin with the presentation.
Here, I think. I can come on here. Yeah, better है ना? हाँ, तो वहाँ पे स्टेज.
Shall we have a big round of applause for Professor Singh? Welcome.
So, very good morning to all. Very good morning to all. So yeah, I think it takes time. First of all, I wish you all World Engineers Day. We all are engineers here, so that's the kind of proud and pleasure we all can feel. And thank you to Chaudhary sir for the invitation. In fact, I got a message from Professor Joshi that this is the event and he has recommended name for this keynote. I could not say no because once you get the command from higher up, so you have to accept and go ahead actually. So it was pleasure and thank you to both of you for this wonderful invitation. So we have 40 minutes, Chaudhary? 40 minutes? Uninterrupted. So is it okay, maybe in between I can also...
5 to 6, 10 minutes.
Huh? Yeah, plus.
Plus or minus.
Yeah, okay. So in between I may switch over in Hindi or English, you know, like depending upon the subject actually. Yeah. So let's talk about that. I hope this slide is visible. You know, like this green color sustainable and resilient pavement infrastructure, it was visible on my computer but not visible here. This is exactly the same thing and luckily it is good that it's not visible here. The reason I am saying good because Professor Joshi also mentioned the sustainability and resiliency. We talk about that but not visible. But anyway we are going to talk about that. So let's go to the next slide. Let me warn you that this presentation is I'm not here to advertise any kind of thing. There are a lot of machineries, some photographs will come, and my intention is not to become, you know, like somebody's agent and present it here. But the intention is just to give the input. Go to the next slide. Particularly, these are the two roads. We are going to talk about either bituminous road or concrete road. Go next. These are the different activities that we talk about. Either it is new construction, or you may have the strengthening and widening, or you may have the rehabilitation, intersection, ramp, or you may have the urban roads, specialized locations, bridges, rural roads, repairs, maintenance, recycling, so many things actually. And all things are different. You cannot just mingle things together because all require different specialization. For example, urban roads. It's not as simple as national highway. More challenging and more, you know, like timely attention has to be given. So sustainability, in fact, we talked about that. But I feel this is a kind of buzzword actually that we have really started listening a lot. Not now, maybe last 15 years. Construction has to be sustainable. Development has to be sustainable. We need to follow the sustainable practices. What are those actually? And what practices really we need to implement? Are we really following that? If it is so, then we don't need to bring the aggregate which is coming from 400 kilometers away. What kind of technique we are using? Particularly because my area is road construction, so I'm going to only focus on the road construction. But you can always link this sustainability on other fields also. So, for example, there is a concrete road, there is a recycling, there is a stabilization, there is a construction. All they have the different kind of carbon emissions. And we also heard Professor Joshi about that carbon emissions are different for different activities. But are we doing that? For example, if you see this particular thing, the PMGSI road, which is like the roll roads, having your typical infrastructures, I mean the composition, list carbon emissions, but if you see the concrete road, which goes highest carbon emissions, how do we change our practices for the construction? That is the kind of question that we need to follow. Now again is the resilient infrastructures. We are talking about two terms here, one is the sustainable, another is resilient. Sustainable takes care in terms of the material selection, in terms of the life cycle cost, in terms of your carbon emissions, in terms of your utilization of the waste product. Resilient infrastructure means how strong you have which can cater all this impact. Extreme rainfall, all roads has gone, flooded, washed. Whatever construction you do, it is not working out. High temperatures, lot of failures are happening, and high intensity earthquake. In fact, nothing is in our control. What is in our control is how do we understand those factors and then design our things. That kind of things we have to take care of. These are the challenges people are aware about. It's nothing new that I am putting up here. The scarcity of material. In fact, few days back I was on one of the site visits and it was mentioned that the aggregate has been transported from almost 400 kilometers away. One truck. One truck is coming from 400 kilometers away. Now think about the volume of the aggregate which is required for 100 kilometer of roads. How many trucks has to be transported? What kind of volume of the aggregate we require? And by the way, once you consume one particular hill or mountain, it's not going to go up again. It's not like after 10 years again it will start growing and then you will start getting it. It's done. Once you consume it, it's over. So that gives the sense that we need to really think about something which can help us to remain or retain this kind of aggregate. Other thing is the premature failures. In fact, I will show you a couple of photographs and a couple of case studies also here. A lot of failures. Premature failures. Within 1 month, within 2 months, within 3 months, within 1 year, all kind of roads. Environmental issues that we already talked about that. City challenges. There are a lot of city challenges. Traffic overloading. If some of you are working on some REST-LIVE or some other projects, a lot of overloading is happening. I don't have the data here, but I can show you the on-site data, how the overloading is happening. Rainfall, temperature, climate, high cost. Everybody wants to cut down the cost. How to cut down the cost? Keeping the engineering science in the mind actually, which is not there. Waste management, sustainable practices, investment plan and policies. So these are the challenges that we have right now and we need to focus on it. How do we tackle as an engineer, we have to think about that. These are the different factors. Any road if you construct, typically you are going to see all these features. There is a temperature, there is a climate, there is a traffic, there is a rainfall, all these factors. And you need to take care of all these factors to ensure that there is no failures or premature failures on the highway. You must have seen these photographs. Last year this kind of photographs was quite popular. Again the summaries started coming and you start getting the same kind of things coming up again actually. You are going to see this kind of blooded almost actually everywhere. What it indicates? The kind of temperature that we have been experiencing now actually. And as a pavement engineer or construction practices, what changes we have to do? How do we select the materials? How do we mitigate this kind of impact? At the same time, you can also think about the rainfall. At the same time, you can think about other challenges also. So we are going to talk about that, how do we tackle all these issues. In fact, if you see the temperature going even up to 60 degrees Celsius, and air temperature may go even in Gujarat maybe more than 42 or 43. How do we tackle that? That is an important thing. And you must be seeing this kind of failures, many of the places. You may see the road has been constructed within 2 years or 3 years, you may see the failure has come up. And if you ask the region why it has happened, if some of you are involved in the construction of the pavement, overloading has caused this issue. For subgrade is a problem, for contractor has not done a good job. There are 100 things you can blame it and not find the answer at all. But we need to figure it out. What exactly happened in these 2 months? What has happened to this road? Right? You may see the crack. The pavement looks good, but it has been cracked. We have invested 100 crores, but again we have to invest within 1 year. Again you pump more money. Again the material cost, resources, manpower, funding, budget, policy, everything will change. You will see different kind of failures actually. Next. And you will see this kind of failures also. One side it is a lot of cracks, other side a lot of bleeding is also happening, lot of this rutting is also happening. Something is definitely going on wrong actually. Either we have not understood how to construct the road, or we have understood how not to construct the road actually. And then somebody told that, okay, this kind of roads have the problem. Let's not go for the bituminous road. They are always problematic, let's go for the concrete road. They are the good, they are the best. And I will show some examples. In fact, in Maharashtra, in Gujarat itself, there are a couple of roads which have failed within 1 month, within 1 year. You can see kilometer and kilometer of cracks coming up. So it's not that you think this is not working, let's work on that. Unfortunately, in the civil engineering, there is you all have the mobile phones. Every day you get the updates. Your software is getting updated, please turn it on. And your mobile gets updated and you understand that it is happening. Unfortunately, in the construction field, we don't have the updates. We updated, constructed. It's not like after 2 years, let's update that road and it will be brand new. No updates, no bugs. Decide at one point. If you want to do good quality road, plan it, execute it. No plus and minus. So definitely the simple margin of the error can cause a lot of issues actually. Again, I think this is, I remember I was traveling somewhere in Gujarat last year and I could see some trails of these kind of things. You see, the pavement is trying to tell you that there are some issues, please try to help. Whoever done the construction, it is fine, but there are certain issues which is happening. And if you don't tackle these kind of issues, maybe in the next project or later on, of course you have to pump more money. You may say this, road looks completely off. And you ask the reason, because the subgrade has gone, almost like if you see the water which has gone into the subgrade, and settlement has happened, widening has completely gone. What is the solution? Reconstruct. Where to get the material? You remove, throw, bring new material. Okay, absolutely okay, simple work, straightforward, but a lot of money, a lot of cost is going to go actually in that. You may see this kind of issues also, which indicate that there are certain things we need to improve actually, which is not working out. You may see this also, a lot of potholes. In fact, I am from Mumbai, and every year in the rainfall season, for example, it will start in June, and June, July, August, September, October, you are going to see the newspaper is flooded with the potholes. A lot of potholes, but still we are not able to solve the problem. For the last 40 years, 30 years. And maybe, like MCGM spent maybe more than 50 crores, even 100 crores, just to tackle the potholes every year. It means something is definitely going wrong, which we have not found the answer, and we have to, work in that direction. Another black cotton soil. In fact, in Gujarat, the black cotton soil is quite large. And by the way, don't get afraid of the black cotton soil. If you see the black cotton soil, doesn't mean that it is a problematic soil. There are certain ways to analyze that. There are certain ways to understand that. And yes, if you don't understand that, if you construct the roads, you may see the failures. Because the black cotton soil has is very peculiar feature. It is going to exert some kind of pressure from the bottom and your pavement will fail. You need to understand. Concrete pavement. It's not like I'm just highlighting you all about the bituminous pavement has a problem. Concrete pavement also has a similar thing. Many of the concrete road, in fact, you all are involved, that failed within a couple of years, within 1 year. How do you maintain? What kind of technique has to be used to maintain the concrete road? And people, those who are involved in the concrete road, they know that how difficult it is to maintain, how difficult it is to repair, how difficult it is to open for the traffic immediately. In fact, somebody was asking me, sir, we wanted to construct a concrete road, we wanted to open next day. I said, I don't know the magic, maybe somebody may know it. If you wanted to construct concrete road open within 24 hours, maybe some technique, maybe expert can tell. But yes, it requires a lot of experiment, a lot of understanding of the subject. And if you can evolve the technique, but who is going to change the construction practices? That's what we need to think about that. Go ahead. You see this kind of cracks? And see this middle crack which is going on longitudinally, kilometer and kilometer. What is the depth? Complete crack. 300 mm thickness has gone, separated in two. Why is it happened? Contractor was not good. That is straightforward solution actually. Contractor was not good, or if that is not working, maybe the QC was not good. Quality control was not good. Third thing, maybe the like engineer who was there was something going on actually. All the roads like that? Or we have to have certain ways to understand that what exactly is happening. And then people start doing stitching. You see this first slide is stitching. Like we do the stitching of the clothes. You can do the stitching. But how long it will work? Whether it is really going to work or not, that those kind of questions has to be answered. So what we will do actually, this particular presentation, I will focus more on the flexible pavement, those kind of techniques that we are using nowadays. These are the possible regions for the failures. Traffic is a problem. One of the highways recently, in fact, if some of you are on the design side, we use one factor called VDF, vehicle damage factor, for the design of the highways. How much severe the load is. And in the design that VDF was assumed 5, it is number actually. But if you do the actual survey on that highway, the number was going on 40 to 50. And in fact, a few days back I had a detailed discussion on that particular factor, that just assuming that 5 out of 40, it is not going to help you. You need to tackle it. How do you tackle it? So government is not bringing the policy to stop the overloading section. It will never happen. It will happen, but it will never happen, or it will not happen, whatever. But you have to have the engineering sense that how do you tackle the problem? There have to certain ways to handle that. Maybe the temperature issue, maybe the material, maybe the pavement design, construction practices, quality control, moisture, may be unknown for some region which cannot be disclosed. But pavement has failed. And these are the facts actually. It's not like something which I'm showing you first time, you all know about that. This is what we think that we have good control. We assume that we are good control, we are a developing country, and then we assume that everything is going as per our plan, but what I sense that we are not in the control actually. We assume that our workforce is trained. Whoever is doing the construction, roller guy, paver guy, like the plant people, or maybe the site engineers, they all are trained actually. We take the assumption. And yesterday somebody was driving truck, today the guy is driving the paver or the roller. They have no idea like what is the roller function. They only know put the gear and go ahead actually. So that kind of sense, we need to start digging down the root cause actually. Where are the problems? We assume that we have the good construction practices. We assume that. But we don't have the good construction systematic way to put up the things on the ground. We assume the roads, once it is constructed, is going to be problem free. But we see the problems. We assume we have the plant, machinery, manpower, reliable data, everything. But trust me, I have seen so many designs or so many kind of documents from the plants. I have not seen any mistakes. Everything looks perfect. In fact, those who are involved, they can also work. No documentation is done for someone to find the mistakes. Documentation is done to make sure that everything looks perfect. And we have not found any kind of issues on any documentation. No quality control data has been manipulated. Everything is crystal clear, fair. But that's how the thing is. But in reality, it is not the case. So these are, no, go back. These are the issues that we have to tackle. And these are the burning issues, by the way. And we are assuming that things are working as per our plan, but it's not working out because there are a lot of things which we need to recalibrate ourselves, correct? So what is going to happen? Is something magic is going to happen someday, or suddenly something will change? Of course not. We need to do something to really construct the road which is going to last. In fact, I was hearing Professor Joshi also, he almost summarized today's lecture in a very nutshell. Beautifully, he has put up a lot of interesting like sentences and words. What we'll do actually, we need to rethink about what kind of construction practices that we have been using. What is the techniques, what is the technologies, what is the practices, what kind of quality control, what are the existing systems that we have. We need to work on that first. We cannot keep on thinking the technologies. Okay, this new technology has come, implement it. This new technology has come, implement it. But first of all, you have to think what exactly we are doing. What is our SOP? What kind of things we have been doing. This is what we have to understand. What quality of the payment are we constructing? Verification of the designs and implementation part. In fact, today morning also I was having some discussion with one gentleman, and we were thinking that everything is going as per the plan. But reality things keeps on changing actually. The ground realities are different, and there are a lot of issues with that also, because contractor has the pressure, there is a political pressure, there is a time pressure, there is a budget crunch, there is a safety margin, there is a cost margin, and everything has to be keep in balance actually. So you may find some compromise has to be done sometimes actually. Next. So what I will do actually, I will cover a couple of technologies for you just to show you that what are the different technologies which is going on in the road construction. Maybe you can pick up some and you can think about that, how do we implement. Think about the implementation side. And I will show the example which has been implemented on the ground. So there are nothing fancy which is going to be shown here, that all in the paper. It is on the ground actually. We have been doing that. And why we have been doing that, I will show you that what are the benefits of those kind of techniques. Many techniques are there. And I'm not going to cover everything actually. There are many techniques. If you really wanted to construct good payment, flexible payment, there are certain techniques. If you wanted to do concrete payment, there are certain techniques. If you wanted to preserve the payment, there are certain techniques. If you wanted to maintain it properly, there are certain techniques. If you wanted to use waste, recycle, plastic, stabilization, there are certain techniques. If you wanted to do overlay, concrete overlay, flexible, there are certain techniques. A lot of techniques are there, but yes, as an engineer, we also have certain challenges that which to use where and why to use it, keeping the cost into the consideration. There are many techniques actually, which I'm not going to go in detail, but later on I will give the focus on that. These are all different techniques that you can think about that, but I will show you later on all these things. Go ahead. But the technology is not going to help you. It's not substitute of the poor paving practice. We have the perfectly wonderful clients nowadays. Machineries are good. All imported machineries are there in the road sector. We have the good plant, imported machineries, but the paver, like the poor paving practice is not going to help you. You have to improve that. One change is done, but other changes is problem. So you have to combine, you have to practice on that actually. So next. So this is what I think should be implemented. Maybe you can think about any other direction also, but in terms of the construction, road construction side, I understand you need to see the technology, technical support. Training is important. How do you use the techniques? Because sometimes we heard that, okay, use this technique, but people are not aware about it. Now if you see the technical support which is really needed actually to implement it. We have the quality control mechanism, we have the acceptable policies, data and performance feedback. So this is one example, and well, I'll show you this is a road near around, in somewhere in Rajasthan, and you can see within a couple of months we could see the rutting has happened. Solution, mill, again construct. And this is happening, you know, like trails and trails going on actually. And somebody says the bitumen quality is not good, we have to change the bitumen quality. Or we have to mill maybe 100 mm, relay it actually. That's fine, the solutions are there. But why is that happened? As an engineer, I need to understand it should not happen again somewhere. So those solutions or those regions I need to figure it out. What I will show you, go next. Next. Yeah, go ahead, go ahead. Yeah, go ahead. So what I will show you actually, there are certain tools and techniques which people have been using it just to simulate the field condition in the lab. We have not been using that particular test in India right now. But there are certain tools that you can use for understanding whether your mix, whatever mix you are preparing in the plant, it is going to work in the field or not. And I will show you some video next. There is video actually possible. Not there? Yeah, okay. So what is happening? This wheel is on the samples, a bitumen sample, and it is going to travel. And it is applying the load. You are simulating a couple of things here. You are simulating temperature, you are simulating the field condition, you are simulating the loading, and you are trying to figure it out whether your material that you have selected, whether it is going to work or not. Pass and fail. It will pass, it will fail. And we have seen many of the mixes that, based on our experience so far, many of the mixes are not going to sustain this loading. It means on some of the highways, if you have overloading, or some of the highways where your mix is not good, or the selection of the binder is not good, it's not going to work. Don't waste your time on that. Don't construct and invest 100 crores and again come back and again invest similar amount. Do some work, bring some data, bring some performance tests which is going to help you. And these are the certain tools that we can use actually. Not only for the national highways, the state highway, in fact for the urban roads also. Just to ensure that to optimize the cost. That is also possible. And these are one of the samples. Once you apply the load, after 20,000 passes, you can see the rutting is happening, which is deformation is happening. Next. Some of the samples has gone. It means some mixes are good, some mixes are not good. You can use it, you cannot use it. What changes to be done now? Somebody said change the aggregates. Way to change the aggregate. I am already bringing from 400 kilometers. If you ask me to bring 1,000 kilometers away, where to bring? Cost is going to go up. What changes to be done actually? I have no options at all. So sometimes we need to innovate things, and the innovation has to come up next. Sometimes you may find perfect. There is no damage at all. And many of the mixes or many of the construction practices that we have been using, they are the problematic. Either we rethink or re-innovate ourselves, otherwise we have been keep on doing the same thing again and again, maybe next for 20, 30 years. Next. If you are involved in the bitumen construction side or the pavement construction side, we add bitumen into that, and bitumen is the glue. If you add a lot of glue, then there are issues. If you don't add the glue, then again also issues. You have to have in between these two actually. For example, if you don't add any glue, a lot of potholes, a lot of leveling is going to happen, and which we have seen on many of the highways. If you add a lot of glue, then definitely a lot of trails are going to come up. So you have to in between it. And this is well established practice by the way. All engineers, those who are in the road sector, they know how to balance things. How to determine the optimal bitumen content. All the people. They can do calculation, they can come up with the numbers, they will say this is the right number, you go, you construct and you see the problem. It means there is not right things. I mean something is going on actually. We are not really following the right practices. What I will do, I will cover briefly about the recycling. In fact, what I have done here, there are a couple of techniques that I am going to show you. So field practices, and which is being used in the field. There is a two technique which is going to really fit into the recycling, or the sustainability. resiliency and sustainability. So for example, there is hot recycling, there is a cold recycling. You can use 100% material, no need to bring any new material at all. The existing payment, once it is lived the life, you can use 100%. No material is required from anywhere. Those techniques are mandatory in many of the countries. Many of the countries, mandatory. No option at all, you have to use it. Sir, I don't have the machinery, I don't know. You bring it, you have to use it. Change the way. And now in India, what is happening? Many of the projects are coming up. Yes, there is a lot of work is required, but and in fact, our infrastructure is also huge. If you see the road network, we are like the second largest. It means the consumption is also second largest, or maybe the more actually. If you don't think about the innovative techniques, then definitely the issues are going to come. This is what we see sometimes. Next. This is what we see. Sometimes the material is like put up. I remember I visited one of the sites, and the contractor has almost 19,000 tons of RAP. 19,000 tons. Excavated, put up on the plant. And I asked him what you are going to do with this RAP. This RAP is a mill material. Sir, we don't know what to do, we'll put in the embankment. That is the best way. If you don't know anything, then put somewhere. At least it is like material, it can be used. Remember, this is the black in color, this is the black gold actually, you can say. It has the bitumen also, it has the aggregate also. You can save two things together. You can save bitumen, you can save aggregates. Nowhere you are going to bring it. Everything is there. But we need to understand how to utilize that. Go ahead. This is what I was showing you. This is exactly the photograph from one of the plants. And it is dumped there, assuming that it will be used, but it will be used somewhere in the embankment or GSB or WMM or filling some kind of service roads or something like that, but not really very insensible way actually. If you have seen the milling, what you do actually milling, you just mill the material. All the material has to be milled. Adjusting road is there, you mill the material, like the way the milling is happening, you put on the plant. And I'm talking about the hot recycling by the way. Hot recycling in the sense that the recycled material has to be hot. We have to heat it again. But there is a cold recycling also where the recycling material should not be heated. So I will show you both the techniques. Go ahead. There is another technique called hot in plant recycling, hot in place recycling. Sometimes what happens actually, like milling the material, taking to the plant, which is 100 km, 40 km, it doesn't work actually. It is not cost effective. But then there is another technique which has come up, that hot in place. No need to bring the material anywhere. Bring the machine on the site, go next. Heat the material, go next. Bring the machine on the site, heat the material on the site itself, mill it there itself, and lay it there. So you are not milling it, you are not transporting it, you are not investing any money into that, just all machine on the site, and immediately after that you can see. And this has been used on one or two projects actually, not only one or two, I think a couple of projects has been done using this technique. The Ranchi Ring Road, which is quite famous, which is done using this technique, in place recycling. Some of the project which is going in the south using this technique. And hot recycling, what I showed you earlier, that has been quite popular nowadays in India. Another comes cold recycling. So now we have covered hot recycling. In hot recycling, you have the in plant, in place, depending upon your project, depending upon the site conditions. Cold recycling, no heating. And cold recycling also two types. One is the in plant, another is in place. And this machinery is going to show you in place recycling. Next. And there are like little bit more technical details which I would not go into detail, but what material has to be used. In cold recycling, you have the material, you have the emulsion, or you have bitumen, you have add certain cement, percentage of cement and use it. No heating is there. No need to bring the material on the plant. Next. Go next. Yeah, this kind of roads, no worries. I'll show the case study actually. So this is the case study that I have got from the field. Usually what happens, you see a lot of roads like that. And what is the easiest solution? The easiest solution is just to remove that, reconstruct. Forget about that. Remove, reconstruct and bring new material and then do the construction. Or you can construct overlay on top of that. Or you can do recycling. What I am going to show you the recycling. So next. This is one of the project actually. So next. This is the condition of the road, what you see in the top, existing condition of the road. By the way, this particular project, recycling is happening on the site. Existing road, no material from outside. Whatever the material is there on the pavement, we are using recycling that particular kind of material. You see the existing condition? So next. What we have done, we have spread lime, cement. It depends actually. But typically lime or cement are widely used. Cement plus lime combination, sometimes fly ash, sometimes lime, depends. Same road, the cement and lime had been spread. Existing road. Spray the lime, we spray the cement, and dosage has to be designed by the way. This is the one machine which is used for in situ recycling. In situ we are talking about. And this particular recycling machine is going to mill everything, mix everything. Your cement, aggregate will be mixed together, depending upon what are the thickness. Maybe 100 mm, 150 mm, depending upon that, you can do that. Milling is happening on the site. And then once the milling is happened, you need to grade it. You need to use the grader just to make the profile, because the layer is coming on the top. Correct? And then you roll it. A big roller is required. You cannot use 8-ton roller. A roller has to be at least 18 to 20-ton roller, because the mix is cold and you require big weight actually. We have seen people are using 8-ton roller or maybe sometimes heavy rollers. It's not going to work. Even though you are using the technology, but you are not using the proper tool to execute that. So that is very important that you understand how to execute it. Connect. And this is how it looks like. No material. And this is how the recycled surface looks like. Connect. And this is after the drying surface. Connect. This is another project which is recently I visited this project, which is the plant recycling. Remember the earlier one was on the site, in situ. This is in plant. You bring the material, put in the plant. Correct? This is how the screening is happening. You bring all the wrap on the plant, you do the screening, then there is a plant here, you're mixing emulsions and everything in there, and using the paver. Paver is there, and this is the truck. So bringing the material, by the way, this is cold material, there is no heat in there, no emission at all, no heating, no emission. And you can bring this material, you can wait maybe a couple of hours, it's not going to set. You can wait 2 hours, 3 hours, the workability still remains there. And this is what it is. Since there is an emulsion, if you see the left side picture, it looks little brownish in color, coffee color kind of thing. But after a couple of hours, it turns into the black. The emulsion breaks, and after the emulsion breaks, you can see the black in color, and it looks like a brand new road. And there is a material saving, there is a transportation saving, there is a machinery, and everything. All these kind of components are going to help you to optimize the cost. Next. And this is how the things look like. After that, you put thin overlay. Maybe 30 mm, 40 mm, depending on the design, and your road is brand new. You have used hardly 10% of the new materials, and you have used existing material as it is. So these are the benefits. I mean, if somebody is using the recycled material, a lot of benefits are there. Environment benefit, cost benefit, material benefit, good roads are there, maintenance free, you can remove the distresses what are there actually, you can like rectify all the kind of calls for the distresses. Okay. There is another technique which I am going to tell you about, the stabilization. Remember, the recycling is hot recycling, cold recycling. Stabilization starts from the bottom. You can do the subgrade stabilization, you can do the aggregate stabilization, and you can improve the quality of the material. Go next. So go next. I will simply go. This is what it is. If you have a stabilized material, for example, there is unstabilized granular base, there is stabilized. Once you stabilize something, definitely the property will improve it. You can add cement, you can add lime, you can add fly ash plus cement together, either in subgrade, either in aggregate, GSB, WMM, and you can improve the quality. Why it has to be improved? Because there are certain benefits. The pavement is going to become stronger, moisture damage is not going to happen, cost saving is also going to happen, and which is in the practice nowadays in India. Yeah, these are the benefits. Many of the places we have seen the water table is quite high actually. The water table is quite high, it goes into the subgrade and then GHB and then deformation happens. You can break that, you can cut off. If you do the good stabilization, quite possible that you can cut it off. So water is not going to come in the other layers because the capillary action has been cut off actually. Yeah, go next. These are the designs as per ISE 37/2018 or 12, but you can always design the payment. Okay. This is one of the projects, again I will show the field example. So where we have done that and how it has been done. That is more important, that whether it is in practice or not. Go ahead. Again similar kind of machine, this is a GSB on the side, granular subbase which has been dumped on the side. Next, you spread it. Next. This is the bag, this is how it looks like. GSB, spread it, compact it. Then you spray the cement on that, or lime, depending upon what kind of combination is going to work for you. Then this is how the cement has been spread. What we are doing here, we are stabilizing the aggregate layer. Why it is so? Because we wanted to reduce the cost. Or your aggregate quality is not good. You wanted to improve the quality of the aggregate, in fact, the quality of the layers. So therefore, we require this kind of stabilization. Go ahead. Again, similar kind of machine, in situ. You can do in the plant also actually. So nothing is not like it is always in situ actually, because this machine is going to cost you maybe 10 crores. It's not necessary that you always do on the situ. You can do always in the plant also, depending upon the logistics. You can use the WMM plant and you can use all these techniques. Go ahead. Again, the grading is happening. Okay. Rolling. Again, the heavy compactor, you require 24 tons, 20 to 24 tons, so that it can compact properly. Okay. This is how the bed look like. Okay. And this is how you check the quality of the compaction or the layers. Okay. And how the curing has to be done, because there is a cement in that. Around 2 to 3% cement is quite enough. But if you are going a little bit more stronger, then cement dose has to be increased actually. Maybe it can be 4%, maybe 5%. Yeah. And this is how things look like. Very strong layer. It's not going to deform it. Very strong foundation. And on top of that, if you put the recycled material, for example, if you have wrap material somewhere, if you put on top of that, you are saving here, you are saving there. A combination of the recycling technique can be used. And some of the projects that if you do the combination of the recycling technique, then definitely you may save even 60% cost. But yes, execution is important, the planning is also important. Again, similar kind of soil stabilization, go next. Go next. This is one of the projects that I will show you, soil stabilization. Aggregate stabilization, now soil stabilization. Because sometimes the soil foundation is not good enough. You have the poor soil. You cannot construct the kind of good subgrade. We have to stabilize it. In some of the highways it is going on. Correct? See how the subgrade looks like. By the way, it is written that cement, but you can always use any combination depending upon the type of the soil. Don't go with the cement always. It depends upon what kind of soil or what kind of, like the characteristics it has.
Lots of additives are also coming.
Yes. You spray that. Go ahead. Then again, similar machine. And stabilization of the soil in situ is always preferred, because you cannot import all the soil. I mean, you cannot take the soil in the plant and bring it back. It's impossible. So in situ stabilization is the best technique to stabilize the subgrade. So next, then roll it, compact it, how it look like. Your CBR improved, your moisture damage characteristics has improved to the strength, your pavement thickness has cut down, your cost has come down, your life cycle cost is going to come down. And you check the density. So next, and you have to it. So what we have covered so far, to maintain the recycling we have done, old recycling in the plant, old recycling on the site in the plant. Then what we have done, stabilization of aggregate layer, stabilization of subgrade layer. So we have covered stabilization and recycling. These are the two very strong pillars nowadays. And they can be implemented depending upon what kind of project you have. And whatever material is there, you can use 100%. There are some other techniques which I am going to cover. By the way, I am not going to cover a lot of things on the white topping and short panel because Patanjali is going to cover that. He may tell me don't cover that actually, I will cover everything. So I will cover a little bit brief actually, but keywords.
If you will cover that, I will be enriched.
Yeah, a little bit. Yeah, go ahead. By the way, many of you must have heard about this particular technique, SME. Strong mastic or matrix. If you have not heard about that, because there is this is the time, because this particular the mix or this particular technique, it can help you if you have really rutting issues actually, or if you have moisture damage sometimes, and there is no option to go for the concrete road. Then this is the technique which you can also think about. Go next. This is about aggregate selection. I will not go into detail about that. I will show you the picture actually. Go next. Next. How the things look like. You see there is two difference here. One is this mix, another is this mix. This is your typical BC or DBM. Like you are using BC, DBM or for the construction of highways. And this is SMA on the right side. You see the clear cut difference between these two structures. Your SMA looks all the coarse aggregates are coming together. And your BC and DBM, one coarse aggregate here, another is here, another is like this. They are floated actually. So we call the aggregates are floating in the matrix. They are floating in the matrix, but here they are stone to stone contacted there. So once the load is applied on this one, definitely there is a lot of chances that it will not deform. But here it will deform. So if you have heavy loading, high temperatures, high chances of getting rutting, then definitely there is a good choice to go for the SMA. And you can think about that how to build a road. In fact, this is the practice now. Delhi-Vadodara Expressway, which is the perpetual payment, you see the top layer is SMA. In fact, other road, the Chennai-Bangalore Expressway, top layer is SMA. Another which is Delhi-Katra, top layer is SMA. Nowadays, SMA has boomed actually. But we have also seen SMA has been misused actually on many of the projects. It also gets failed actually. So again, the technology is not going to help. Implementation is important. How do we implement that? So next.
There is a new word. Technology is not to be
Blamed.
It is the intentions how you apply it.
Yes.
The new word.
Absolutely. Yes.
Intention.
Yes. And this is the example.
Yeah.
And one of the projects where the SMA was used, truck was loaded, and you can see the bitumen is dripping out of the truck. Have you seen the bitumen is dripping out of the truck? And impossible actually. If bitumen is dripping, it means the bitumen has become liquid. But bitumen was dripping out of it. It was, if you can keep some container, maybe after half an hour you will see half container is full. And if that happens, definitely the road is not going to work. And this is the nature of SMA by the way. If you cannot handle it, then there is a problem. Yes. And then definitely there is a lot of fibers in the market now. A lot of fiber has come up. Use this fiber, use that fiber, use this additive. In fact, the stabilization also we are saying that a lot of additives are there. Somebody having liquid, somebody having powder, somebody having different color liquid, so they say use this, use that, use this. But I tell you what, if you go anywhere in the world actually, US and Europe or somewhere, the maximum utilized additive is cement. Cement, lime, lime. And you can do wonder with these three materials actually. You don't need anything, like colorfuls. Nothing actually. But if you see the kind of approaches that we have used, use this liquid, use that liquid, use this one. But I think it all depends actually. How do you characterize your material and how do you make your stabilization layer. Likewise, this also fiber, a lot of fiber has come in the market. Some fibers are working, some fibers are not working, some fibers are getting burned into the plant, and then you see the issues coming up. By the way, this is the same test, the rutting test. The wheel was traveling actually. You see the rutting here, one sample has become colorful, it's whitish in color. Lot of moisture damage has happened. Water has gone inside, and after the water has gone inside, a lot of fines have come out. Raveling is going to happen, stripping is going to happen, potholes are going to come up, and your SMA is not going to help you. until unless you strengthen your bottom layer. You make sure you cut off your moisture somewhere. How to cut it off? That is based on the design. How do you put the mix actually on the film? But if you see the right side, another SMA which is hardly 2 mm rutting. And you have seen other samples also earlier. The complete sample was collapsed. So these are the techniques and tools that you can utilize for construction of the good kind of highways. Okay. These are the field photographs. This photograph was taken from this Delhi-Vadodara Expressway, which is recently, opened up a few months, 1 month back. And where the top layer is all about SMA actually. All about different kind of, design, different kind of fibers and all that we use. Microsurfacing is also, you all must have heard about that. And it has been used quite widely now for preservation. But we have also seen people are misusing this particular technique. They are used that preservation means you can preserve anything. Concrete road can also be preserved using microsurfacing. Bitumen road can also be preserved using microsurfacing. Rutting can also be preserved using microsurfacing. Cracking can also be preserved using microsurfacing. Any issues can be preserved using microsurfacing. Those are the claims actually. Overloading is there, use microsurfacing. See, you have to be careful actually. This particular layer is a cosmetic paint actually on the surface, nothing more than that. There is no structural capability of this layer to handle the load. If your road is good, you make sure that it remains good, you use this. It is kind of a painting on top of that to improve the riding quality. Remember, to improve the riding quality, little bit, not very significant.
50 mm, not more than that.
If you say a lot of bumps are there on the highways, use microsurfacing. We have seen some of the highways, a lot of rutting was there, somebody projected microsurfacing, they did microsurfacing, after that it failed. And after that you don't find their microsurfacing vendor actually, they vanished, they went to other projects. So we have such a diversified community that we don't know where technique is being misused and where it has been used.
It has been used in Surat extensively.
I think Surat Municipal Corporation has been using for quite some. Yes. Yes.
They wanted to do microsurface.
Yes.
White
Yeah.
PMM.
Yes.
5 years performance guarantee.
In fact, recently on one of the highways it was used on the concrete pavement. I don't have the photograph, but I told not to.
What they do when they told the tender itself along with BC, they
Micro.
microsurfacing and they call us GFN BC, now we do microsurfacing.
Yes.
Immediately.
Yes.
Yeah,
Yes.
yeah. And it is the only city in Gujarat
Yes.
or India which
Yes.
does extensive microsurfacing.
So one of the concrete pavement somebody has done microsurfacing. By the way, what is microsurfacing? Is like polymer modified emulsion, and you have aggregate which is smaller in size.
Yeah.
Thickness can be 6 to 8 mm.
Five grinding.
Yes. One of the concrete pavement this was done, but this is fast technique. I mean, you can construct kilometer in 1 day. After maybe couple of days, the concrete pavement and microsurfacing has gone like this. Lot of uncoating, everywhere you can see the patches coming up. And if you ask that why it has happened, maybe the rainfall was there, maybe something was there, maybe overloading has come up, maybe something has happened. Maybe the immersion is not good at all. So somewhere something has to be blamed.
But in SMC, particularly so this microsurfacing is performed very well.
It will perform. Yes.
Particularly for not penetration of the water
Yes.
during the heavy rain.
That is
Yes.
only the thing.
Yes. If you can apply that professionally and technically on the right road, it will preserve. No doubt about that.
But it never lasts
They
more
have
than 2
procured the
years.
machines.
Three
also.
to 4 years.
Not more than 2 years.
In one of the national highway, which is newly constructed by the way, one of the national highway, I am giving an example, but I will not name the project. Newly constructed national highway, not open to the traffic. After one rainfall, 1 kilometer lot of graveling has happened actually. Lot of graveling and streaking graveling has started. The agency decided to do microsurfacing in 1 kilometer, the remaining is BC actually. I said if you do microsurfacing, your half lane will be microsurfacing, other will be BC, or after 1 kilometer something else, without before open for the public. And it will be outcry actually. Public will say what you have done, different textures. Here micro, here BC, here micro, here BC. Then finally they decided to excavate and do BC again. Yes, I think good tool, but you need to understand how to use them. But this is a good tool actually. Yes, go ahead. Go ahead. You discuss it. White topping I will not touch much, but as Pathakji is going to cover up later on, a lot of white topping has been done actually in India. A lot of white topping. In fact, it's not now any more new technique. And it is proven actually that this technique is going to help you. And we have also seen other side also. Many of the projects we have also seen the project has been failed actually because of the misusing of the technique. Actually. The design was not good. Existing surface was not good. And then it collapsed. That is also possible. And microsurfacing is your existing bitmix layer, and top of that you put PCC layer, which is 1 by 1 meter, 1.5 meter panel depending on the side. So, a lot of projects are there. I think this is from Pune somewhere. Yeah. Yeah, go ahead. There is another technique called short panel concrete. And this is, I think, in one of the projects what was happening, existing bitmix road, please listen it carefully how the technique has been renamed actually. How smartly, like people have renamed the technique. Existing bitmix road, tender says UTWT is to be done. UTWT means ultra thin white topping. Thin white topping. Yes. Existing bitmix road, and top of that concrete layer is to be done. But when you see the construction practices on the side, you know what they are doing? They are removing all the bitmix pavement. They are putting DLC. On top of that, they are putting panel concrete, 1 meter by 1 meter. But tender says UTWT. This is not UTWT at all. This is like concrete pavement where you have cut down the short panels because all the bitmix pavement which was existing, you have removed it. Now you are doing reconstruction. So now some people have named it short panel concrete because UTWT and short panel concretes are different because here you have the DLC and top of that you have the short panel. And this is also quite popular by many of the places. So sometimes it depends. I mean, you cannot use UTWT. In fact, one of the projects what we have seen, the consultant had proposed white topping. Existing bitmix road, white topping. But once you construct the white topping, then all shocks goes below. Because your level has gone up. So all the buildings and everything gone, like at least 6 inches down actually. Therefore, you have to see what exactly the field condition is.
We have done this in Daman. Daman
Yes.
Fort is there in this.
Yes. Next. Yeah, go next. Yeah, geosal also I will not cover much. Maybe I think Dr. can give some slides, but these are the another technique which people have been using now. Geosynthetics, application of geosynthetics. Cloud gauge, geocell, geogrid, WMM, and GSB. But I tell you one example which is completely extreme actually. In one of the projects, I tell you again, I am giving a lot of example of the project which is real on the site. The DBM thickness was around 250 mm. DBM, like DBM and BCP. And one of the supplier of the geogrid, they have proposed the geogrid into the WMM. GSB and WMM geogrid. Because of the use of the geogrid, WMM has gone from 250 to 90 or I think 80 mm. 250 to 80 mm DBM actually. It is almost like palle for the contractor. No contractor is going to say no to that actually. 250 mm DBM to 80 mm DBM, it's almost 60% saving straightforward. Proposal has gone to the agency. That value engineering has been done on this project effectively. We have been utilizing material saving is there, cost saving is there, sustainable technique is also being.
The underwater metro tunnel. Then we have an ongoing founder tunnel, which also connects the Chandigarh to the city of Manali in Himachal Pradesh. And this is a conclave of the roads, the elevated structures, and 16 tunnels, which can measure up to 19 kilometers in a very steep valley. The challenge is, yes, they have to be overcome, they have to be implemented, but taking 2 hands together, taking 5 fingers of each hand together, and attaining the goals, which are several in nature, not just sustainability, but it is a lean management, it is the quality you have to accomplish with the economical and profitability of the organization. Yes, we have the NG Setu bridge, The bridge is a sustainable bridge we call because we have made use of the existing foundations and created a superstructure which is new in nature. Creation of the existing wealth, creation of the use of the existing assets is our duty. Not to demolish, but see whether they can be used for the ongoing and the future projects. Yes, Jammu Udamam project, one of the fastest project which was initiated about 6-7 years back, and it is the development of NHI with an ambitious goal. So this is what an infrastructure company is supposed to do, and when it does, the responsibility is very high. We have to take our sustainable goals to an achievable time. Next. Sustainability, if we define infrastructural projects that are planned, designed, constructed, operated, and decommissioned in a manner to ensure economic, financial, social, environmental, institutional sustainability over the entire life cycle. This is a quote from the Inter-American Development Bank, which I found surprisingly a very comprehensive document that addresses the sustainable goals. I put up the references. Then we have the World Commission of the Environment. What is that? The development that meets not just the present, but also the future generations to meet their own needs. Next, please. So the four facets of the sustainability. The sustainability should address the economic and financial. It should address the environmental sustainability, include the climatic changes. There has to be minimized carbon footprints. There has to be efforts to see that global warming by use of a right material should be minimized. We don't claim that we eliminate. We say, yes, there is a humble effort to minimize the damage we are doing to the ecology. Institutional sustainability is something, as an organization, we are responsible for. We should have enough management, enough expertise to address how far we are going to optimize, how far we are going to be part of the reduction process in the sustainability, and then how to manage the system with full accountability. Then the social sustainability, whatever the steps we are taking, whatever the projects we undertake, we have to ensure that all the stakeholders have to march together. Each stakeholder has to be benefited. That is a social sustainability goals which we have to inculcate. Next. Next. This is something I need to touch. Just touch it. Creating an awareness that there are 17 such goals of sustainability by United Nations. India as a nation has to adopt each and every such goals and align themselves to the objectives of the nation development. Start with United Nations, start with India, you have to align with these goals, start with your organization, start with your section, start with your department, and start with you as an individual. Align the 17 goals with your daily life. See how much candle light of improvement you can provide to see that our earth becomes greener and sustainable. Next. We as an infrastructure organization, what are our goals? What are our efforts for sustainability? Yes, climate change effects have to be addressed. There has to be economic development in whatever locations we are actually constructing. Jobs have to be created with a local thrust, local expertise, local material, and see that it has tentacles that benefits the area. There has to be a positive impact. As a EPC contractor, the development and nurturing of the client's sustainable goals is our objective. We do have our own in-house sustainable objectives. But when it comes to the project, the sustainable goals of the client are well defined, and we have to align our projects in line with the client's requirement. This is the underlying objectives of any project. Next, please. See what difference we can make. We have established, we have mobilized, there are villages around. Can we do something to improve the quality of village? Yes. Although it may not be stated in the project document as a scope of our project, but yes, we are bound by the social commitment that we need to improve the quality standards of the living, and we have to create a certain sustainable living. We have to create a job. Let us employ the local population and empower them with a job and a skill. Next. Now come to the mechanism, how infrastructure organization has a mechanism of sustainability. See, client conceptualize the sustainability goals for any project. EPC contractor, it carries out the objectives of the client vision and it fulfills all the requirements that are stated in the contract document. EPC contractor incorporates sustainability in his design, in planning, in resource procurement and execution required for the construction. With that, how we use the resources optimally. All the design stage, planning stage are deliberated with several options, option 1, 2, 3, 4, and will come across with the least material requiring option, which can be completed at the shortest possible time. The design life cycle is considered, design is considered using the local material, the construction methodology, equipment used are deliberated and they are optimized. Next please. Incorporating whole wellness program at the sites. There has to be a healthy man hours, timely completion, deployment the environmental experts. Yes, we do that. Especially when it is ecological sensitive locations, it is essential that we take the expert advice in connection with the environmental preservation. Periodic monitoring of the environmental parameters and procurement of the material from a responsible source. Next. Some examples. At our organization, focus on locally available material, soil stabilization, concrete mix design, use of alternate higher performance materials. There are smart materials available. Yes, let us use it. With, as Professor Dharmveer pointed, the core material, it can be used to maximum. Cement, lime, and yes, even the fly ash. Then there has to be optimization in the structural design. Let us use the new technologies to the benefit. If it is able to minimize the thicknesses, reduce the consumption of the material, why not? Lean management is one of the management we as an organization they strictly follow. Out of every 10 projects, there are at least 4 projects earmarked where a concept of management will have to be used and see how the process can be optimized, how the progress time can be reduced, and how the material consumption can be minimal. It is not just the plan, but it is in a measurable systems. At end of the day, at end of the project, we should be able to quantify with the report that this is the saving in time, this is the saving in manpower, this is the saving in equipment, and this is the saving in the money. Money saved by the contractor is the money that goes into profitability. That is a very, very plain business of a engineering contract. So use of a tailor-made materials, let us use the warm mix asphalt. Let there be a curing compound if there is a scarcity of the water in the region. Next. Same sustainability efforts are applicable for our temporary structures. See, for every 5-year project, about 3 to 4 months are used for the mobilization. Many of our setups are the temporary setups. So how we can have a sustainable setups? Let us use a container office, a grid power directly from the grid. Let us avoid the generators. Let us have a solar panel. We have a policy of having a solar panels for our labor camp. We use a recycled water, we use a natural water, and many times we have a bund constructed so that the water that is accumulated, that is utilized for the construction work. Disposal only by the authorized recyclers. We cannot have a material disposed which can threaten the ecology, environment of the vicinity. Let us use the construction waste, recycle it. And yes, focus on use of the alternative materials like fly ash or even the crushed sand. So these are some examples. Next. Mokama Bridge, a few environmentally sustainable projects. Over here we had constructed the structure in form of a steel truss. All the support were GSS based, ground support system and push launching system, so that a minimum damage to the river, a minimum damage to the around soil. Then there is a minimum damage to the river ecology system. Next. Gopalpur, on the eastern shores of India, we had a project situated about 500 meters away from a very sensitive Ridley tunnel nesting locations. Although it was much away, 500 meters is quite far away. But yes, there were some lights we had provided for the night working, which could have been sensitive to the breeding of these turtles. There was a conscious decision in discussions with the environmental experts, the Ridley tunnel expert, and we decided to minimize the illumination in those locations. A small thinking cannot be quantified in terms of the money, but yes, it can be quantified in terms of the sensitivity of an infrastructural agency. Next. Over here, T-74 tunnel in Jammu and Kashmir. Storage water by creation of certain temporary bunds from the natural water, for they were used for construction purpose. This is a very common practice. We need not highlight how we are going to construct, how we are going to preserve the water. That becomes a matter of discussion. But yes, if there are natural sources, use it. Next. A very glaring example of a social sensitivity. Samruddhi Express is an iconic project that had connected the eastern Maharashtra to the western Maharashtra. There are two packages where our organization were involved. In the package number 14, when we actually mobilized, the villages used to go about 2 kilometers to fetch just a drinking water. You can see on the left, the wells are dry. All the ladies is spending valuable time collecting water, come back, cooking. They hardly have any time for any other recreation. This was realized, and we had created a 4 number of check dams just to augment the source of water. And yes, we could see the smile in the villages. This is what the reward is. A smile in the villages, the ladies coming to the office, केवल कुछ बोल नहीं पाते, केवल नमस्ते करते. See, the signs are enough. And these rewards, if we are going to get, it is going to make us more responsible, and it is going to make us realize the importance of affecting every people's life in a positive way. Next. This is the Pandu project, which is ongoing and probably will be handed over to the nation in this year. Mega project, close to about 2,500 crores. EPC, where we have to construct the roads, we have to construct, as I told you, 19 kilometers of tunnel, elevated structure, and yes, there is a Bias river next to it. Any form of widening of the river will have to be protected, and the protection will have to be eco-friendly. With that, the slope protection measures were done with a green fascia. Geosynthetics, a technology used, but we could have had a rigid fascia, but no. Let us blend it with the nature so that green matches with the green and ecology is preserved. This is one. Over here, even the retaining system, we had a soft and the green fascia, and it blended nicely with the nature. Next. There are several and Howrah. They are connected by a perennial river. One such project we had undertaken at Varanasi. And this project was inaugurated probably the last year by the Prime Minister of India. Much part of this project belonged to a marine site, and some of the existing structure had to be demolished. We had to provide a net at the bottom just to see that all the demolition material don't fall on the river. Collect it and make use of it for some of your allied constructions. At MG Setu project, as I told, MG Setu is an example where on the right side you can see where the substructure had been used under the existing condition. The structure had been authenticated by a very scholarly report from IIT Roorkee. They came across with all type of tests and just certified that yes, this material has no distress in terms of environmental damage, although it had served for the past, it had supported the concrete or the RCC superstructure in the past. It had been subjected to the turbulence of water, but yes, it had been proved to be structurally safe to take up the superstructure. We could have had an alternative method of having the RCC structure itself because it has been proved to be structurally safe. We could have had it. But no, we went for a fast, progressive, a steel superstructure. Now this bridge is now handed over to the government of Bihar and it is dedicated to the state. And this is one of the very iconic examples of how an existing structure can be used for the future growth. The trend, remember, is not to be excessively safe. कि नहीं ये existing है इसका तोड़ डालो, demolition करो, नया खंबा तैयार करो, उसके ऊपर आप structure बनाइए. Please, this is an old-fashioned technique. Now we have a technology that can authenticate the structural integrity and the strength of the structure, and please use those technology for the superstructure. Only the thing is now the journals are full of articles which compel us to use the existing structure, which compel us to use the existing foundations for the superstructure. We are still far behind, but yes, the sunrise is seen. Awareness is seen. Use of existing structures. Next. At Ghana, probably we are the first country in Ghana to undertake a 90-kilometer railway project. We also had a sleeper plant with an exhaustive manufacture of the sleepers. Because it was a repetitive operation, it was essential that we optimize the material consumption, reduce the cycling time of the sleepers. Over here, we have introduced the lean management and we had increased the productivity, we had increased the quality of the sleepers, and we had eliminated several bottlenecks in order to achieve the quick requirements of the project. The Ghana Rail Project. Next. Come to the innovations. This year is earmarked for innovation. I have spoken something on the sustainability. A lot of technological innovations have been spoken by the erstwhile speaker. Now let us see what exactly innovation means for an infrastructure company like mine. Next. So innovation should include improvements in the processes, products and services. When I say innovation, I don't mean R&D. Yes, it is R&D. I don't say. but not like a rocket science, which we are compelled to think. Any innovation should bring about the objectives of an infrastructural contract. With that, it involves incorporating new ideas, generating changes that can help solve the needs of the company. Innovative practices, it provides us the cutting edge in the performance. See, we are the competitors. Any tender will be submitted by 10 contractors, and we have to incorporate certain innovation which can save us the material, time, and have a competitive advantage. Innovation is to add the efficiency of the project. Innovation practices increases the profitability. If we don't innovate, we'll perish. The line is as simple as that. Remember Toyota? Toyota had come up with several concepts of management, including the lean management which we talk. They keep on coming with some concepts of management, and you will see the Toyota vehicle is dominating the global market. Go to a single country and tell me that you have not found a Toyota vehicle. This is something not going to happen. Innovate to survive, or else perish. There is an efficient use of the available knowledge. Once you decide to innovate, you'll use your available knowledge, you look out for the deficit knowledge, and you will see that you achieve the innovative goals. It is a systematization of the new process and the product knowledge. Last and the final goal, client satisfaction. Client satisfaction is just a small word. In fact, we should go for a client's delight. Client should be excessively happy. He should come down from his dais and congratulate you. That is what the objective should be. Here I had a privilege of serving for 9 years as a head of R&D at ITD Cementitious. These R&D activities are recognized by CSR. When I say R&D, it may be collection of the innovations from the site people and documenting it. And if they need any support in form of a technologies, in form of a writer, in form of a design support, yes, that was my role as a catalyst. And with this, we have come up with several such innovative products, processes, and changes. Like I tell you, open-end casing driving operations in slag field deposit. If you have to drive a casing in a bouldery strata comprising of the blast furnace slag, you cannot do the piling. For piling, you have to drive the casing, and you cannot drive the casing in the slag portion or any gravel sources. So what we did, the casing, we devised a cutter at the bottom, and we had devised a rotary movement to the casing so that we could rotate it, and the cutter at the bottom could cut the slag pieces. It is to go to the desired depth, and within that we used to bore it. A small thinking, but yes, it can make a difference. Then there is a case drop weight CDW hammer. This is an in-house development. See, if you, the simple thing can be lift up the weight and release it. But that can lead to a loss of the energy, wastage of energy, more cycles of operation. So what we did, we had a hammer, we provided a casing, we provided a frame, and we provided a damper at the bottom so that the high level of energy is transferred to the pipes. Essentially, the hammer were used to drive the pipe. This is nothing but a simple kind of impact hammer. But our own in-house development with the people in the field, they are very knowledgeable. You just have to identify them. They can come up with a mastery of the solutions. So now here, if we come to the present study in my organization of electrons, there is a TBM spare consumption model in which all parts of the country, we are observing what is the progress rate of the TBM in various strata for various TBM machines, and we are compiling it and see what is the progress rate achieved. What are the consumptions of the consumables, spare parts and equipment related to the TBM machine. In tender time, if you have this kind of model, if you have a software model, desktop model, where if you give the input, type of TBM, type of strata, it can give you that this will be the consumption of the bullets, this will be the consumption of the fluids for stability, and whatever the inventories you use for TBM modeling. It is nothing but a compilation. This is assisting us a lot in giving a competitive quote during tender time. Next. Some of the innovative practice, already the GeoSan administrated. Many of our locations where we have access road, where we have roads on the weak soils, plankton soils. At Samruddhi, for some portion we had provided GeoSail technology. At some of the weak marine locations, we use the GeoSails to improve the subgrade strength. Next. PVDs, they have become much a necessity, particularly in the soft soil locations. If you take the last bullet, roads, railways, embankments on soft soil are prone to consolidation. This is a technology which was initiated in India probably in early 90s. And one of the glaring and the first example of use of this was our own Palm Beach Road at New Bombay. A long length, if you had gone to that Palm Beach Road earlier, prior to the construction of PVDs, you would have been standing on at least about your leg depth of very clay. And this is what is the technology that can provide you. It can support a high running loads coming from the traffic. Next. Rapid impact compaction. Likely to be a very valuable tool for all the road engineers. Current trend is to excavate it and then lay the material layer by layer. Now with this, you are going to compact the existing fill, which means the subgrade is available, only thing you have to strengthen it by the impact forces. It means a loose sand can be compacted by repeated blows in a single spot. This is quantified. The energy is analytically assessed, and how much of energy you require per, let us say, 10 square meter of area, you can quantify. Suppose you have a fills. Suppose you have a dumped sanded fills. It can be useful. Let us have a RIC compaction done and have a quantification assessment on the performance for a certain type of structure. You don't say that it will be applicable for a completely long-term solution. But yes, there are solutions, there are ways to assess the performance of even the land fills which are subject to RIC. What is that? Nothing but you have a controlled hammer blows in a specified grade. The hammer weight may be anywhere from 3 ton to even 9 ton, and the influence can be from 3 to 5 meters. Many times you use a surcharge loading in PVDs. If you remove the surcharge, there is still a certain layer of material, 2 to 3 meters. The best thing will be to do the RIC. Remember, not a concept used in India, despite it looks quite simple. But yes, there is a need to introduce this technology in India. We are planning to use it in one of our sites, next please, at Kochi. You see the last button bullet. You find Afcons Kochi site will be planning to compact 2.5 to 4 meter deep of sand reclaimed fill. A sensitive locations of a naval base, and yes, there is a requirement that in future the reclaimed portion may be used to stack the containers. Next. This is the technology to support embankments for the roads, for the stackyards in a weak site. It is nothing but having columns of concrete. It is not reinforced concrete. It is a plain concrete, followed by a load transfer platform at the top. Above the load transfer, you can have any kind of stacking. You can have your pavement. And this load is distributed through the loading platform to the more steeper vertical columns. If you see the design part, there is not such formalized way of designing this kind of inclusion. But yes, even the Fluxus modeling, the software modeling can be done. It can be used to provide a solution by using the rigid inclusion method. We have used in our African projects, but India is awaiting to embrace this technology. The technology otherwise will be having a profuse application into the Indian scenario. Next. This picture of the rigid inclusion. Next. Some of the small innovations, use of the bidirectional test, in which reaction piles can be eliminated, the requirements of the blocks can be eliminated. This can be a fast technology for testing of piles. Next. One of the innovations we carried out at Lonavala project, eco-sensitive location, Lonavala. We go for rains, we go to observe the ecology, the jungles, trees. Let us preserve it, and we had made a small attempt. We would have required an additional pile or concrete block. But during the stage of mobilization, it was not possible. There was no possibility of any equipment going into it. So we have used the in-house available blocks. We have used the anchors, and this is probably the first time in the globe a small thinking was used to test the pile laterally. Small principle of mechanics, which probably the first year BE student can handle it if it comes to giving the analysis of this load test. You could do it successfully. No patents for this, it is for general masses. Next. Coral sand had been used at Maldives for preparation of a city. This is illustration which Professor Dharamveer had provided. There can be importance of CTB. It can realize in the optimization of the thickness of the pavement. Next. So the use of coral sand and what we achieved in the local pavement. Next.
But sir,
there have been significant saving.
in coral sand, how to
I'll
come to the
I'll request for any discussions during the lunchtime
okay.
with due apologies and person hard of hearing. Any discussion, we'll have a face to face.
Sure.
I'll remember that. A coral sand, being a local sand, our plan A decided that we will have a sand imported from India through the barges. The barges coming from the ports of Kerala. Plan A. Then our management systems compelled us to think of plan B, C, D. Compare it by using a certain management principles like lean management and the management of choices. Thereafter, we had replaced the natural sand to be imported with the local coral sand. And yes, here we could optimize on the requirements of the material by completely or locally available coral sand, which was dredged from the Atlantic Sea. there was a significant saving of 9 crores for us. The project is still ongoing at Adur, which is south of Maldives. Next, please. CTB is what had been elaborated nicely, is a common and widely adopted concept in our organization. Only thing which we stress is what has to be used in order to strengthen the subbase, in order to strengthen the base, and what will be the resulting thickness of the pavement. If you don't adopt, you are going to lose the competitive grips. Next. An example of cut and cover. Cut and cover portion, yes, you know that before the portal starts, there has to be a certain portion because of a overburden, loose overburden material. The portion had to be cut. The portion has to be provided with a cover, which is in form of arch or any covering portion, constructed and then backfilled before you approach the portal. This is a typical requirement. At Pandu, next. At Pandu, we had to cut a vertical cutting. If actually we had to operate within the ROW, the slope would have been 1 horizontal, 8 vertical. Almost you can see it is a vertical. That means we have operated within the ROW available. Fortunately, this was a bit of cemented collegial material. It was able to withstand for the construction duration. We had to study the options. What are the options available? Next. This is the background of the project. Next. This is the cut. Next. Option 1. Either you cut as per the ROW, but then you will require a severe population of the bolts. The bolts of 32 mm diameter running up to 12-24 meters. Not a possibility unless you have a caving and unless the slope is destroyed in total. Next. Otherwise, second option thought of was contiguous pipe. Okay, mere construction of contiguous pipe would have provided distress to the slope. Not a possibility. Next. Then we came out what we adopted for this Igatpuri project, Samruddhi Package 4. Have a precast or have an actual in situ arch, cut and cover arch, RCC. But if we are going to spend the time on the in situ construction, any rain, any laxity in the slope would result in the collapse. That is the risk we are going to carry forever. Although widely practiced in some of the stable slope area, but this was not found suitable in a collegial type of locations. Next. This is what was adopted, a precast system of blocks, and these blocks they were converted into arch. For you as a bridge engineer, this is a modern technology which is already practiced widely in Maharashtra. Old existing arch bridge, they are now supported with this technology which we call a modern arch technology. Where, next, a system of blocks are precast. The blocks are trapezoidal shape. Each shape is defined on the AutoCAD. What would be the size and what would be the shape? And at the end, these arch will have to be resting on a socket. The last block we call a socket block. And you can see the blocks are cast on the left side. They are being glued, but each block will be connected by cable. You will understand that. Next. See, now this is a block which are connected. Before lifting, there is a lifting point. Once you lift it, a arch is formed. See, you can, at the bottom, it is lifted. Now it is going to be ready to be placed. Next. Now this is the story. At the bottom, the in situ concrete is done. In situ concrete at left and the right side of the slope. It is beneficial for the slope. The passive resistance from the base offered, and quickly now we are constructing one arch segment, second arch segment, and then passing, and we have a complete arch of the first segment. Next. This is the arch in construction. Above that, we have provided a membrane, waterproof membrane, and on the right, we have provided a PCC topping, which was part of a procedure. Remember, this is a Swadeshi, in-house technology developed by an Indian and adopted for India. Professor takes pride of the students. That is the blood. Am I right, sir? Any student who performs well, who renders services to the nation, he becomes a favorite of a professor. I've been a 16-year faculty member, and this is a technology adopted by my student. So this clap to be conveyed to the student. Thank you. This is a technology which had been developed not by a single stroke of thinking, but yes, a continuous source of analysis. And for your information, the technology which was actually adopted for the bridges was adopted for the first time in India for cut and cover portion. This is what we call a technology adaptation. A small example of innovation for a more resilient world. So there are certain steps. There had been plant methodology, and PCC laying on left and right side of this arch was one of the elements. Next. Waterproofing, PCC laying. Next. This is the overall section. The arch had to be topped with the PCC layer. Once the PCC layer is made, membrane followed by the earth fill of 1 meter thickness, compacted earth fill. It cannot be less than 1 meter. There were strict quality control during the execution. Compacted thickness not less than 1 meter. And with this, we were able to come out with 290 meter stretches of this cut and cover portion, not in one location, but in 3 locations of a very tricky terrain of Pandu Hills. Next. A quick look into, I'll take 5 minutes more before I close it. I know we are short of time. Samruddhi Express Highway is something which was an arena of innovations, arena of new practices and awareness for ecology. Next. This is a section. We have 2 carriages of 240 meter. The tunnel carries 3 lanes of traffic. Earth fill of height varied from 4 to 12 meters. If we went by conventional earth filling, then the section could have been heavy. A small trick of software, a small analysis we have used, we have analyzed, and we have submitted by a soil structure interaction concept. Nothing magic, not a rocket science, a simple documentation of the analysis. Next. So we tied up with our design partner, the Force consultant, and he used the sophistics software in which concrete structure and the backfill soil were accounted together, so that they were just like a husband-wife couple. There was a very successful marriage. The concrete and the backfill soil married together, a soil structure interaction took shape, and there was a long-term marriage, long-term association. And we could see that this marriage culminated into a saving of material for this project. Next. All stages were modeled in the software. Next. Seismic analysis was also done. Next. And this is what we have, a arch. This is an in situ arch. Contrast that with the precast arch used in Pandu. In situ arch, because you can see there is a basaltic rock, highly stable. Our only aim was to save the material. So what we did, above the arch, the material was provided. We had mixed with some quantity of cement, and we had assessed the properties to be used in our modeling. The lab properties were used for the modeling, and to our surprise, we found that the stresses on the arch were much, much less. A small thinking, But yes, it is going to be a trendsetter in the analysis of the art under similar situation. Next. So this was the saving. You can see using the advanced analysis, there was 27.4% saving in the material. Demonstrated. Because our commercial people in the organization, they are far, far more aggressive in committing the requirements of the same. Next. There are management tools which we adopt. Our aim is to reduce the consumption of the material, reduce the progress time, and reduce the manpower and the equipment requirement. With that, we have last planner systems. We have a choosing by advantages, lean management system. They are part of our management system. Remember, infrastructure like us doesn't just thrive on the civil engineers, doesn't just thrive on the accountants, doesn't just thrive on the tax consultants, but they also thrive on the management executives. Remember, we have 6 MBAs in our organization dedicated for just the role of optimizing, dedicated for creating a strategic management for the next 5 years and so on. Unless we adopt these competitive management systems, we cannot survive in this high cutthroat competitive world. So these are some of the 3 examples of management tools which we use and demonstrate in our reports, which are shared to the public in a shareholder meeting, that these are the savings and a culmination of the management systems. Next. Just few examples. Last planner system, plant duration was 86 days, actual duration was 50 days. This is for the Ahmedabad Metro project. Next. Choosing by advantage, adopted at Pandu project. We had 2 options of the shortcutting. It was decided that first layer of mesh was essential for shortcutting inside the tunnel. But whether the second layer of mesh is required or not, that was something of a thinking going on. We have decided if second mesh is required, then what would be the time required? If we eliminate the second mesh with SFRS, steel fiber reinforced shortcutting, there was a certain time. But remember, with these options, with this discussion by a method called choosing by advantage, we could save 180 minutes per cycle in C type of rock and 126 minutes per cycle in T type of rock. Each project comprised of certain cycles divided based on the locations. A saving in the time accrued is demonstrated. Next. KRCL bridge at Jammu and Kashmir. This is one of the tallest pier Indian infrastructure company had ever seen. More than 65 meters of a tower and constructed by a slip-on technique. Over here we had identified several such methods by a lean management. The first one, the rate was 1.45 per day progress. Before lean. After lean, with several such modifications, we could actually optimize the progress to 2.55 meters per day. This applied to several such piers. It resulted in a lot of saving in the time. Next. The final thing which many of us were looking for, the concluding remarks. I asked. Next. I spoke about the sustainability. I spoke about the cost optimization on innovation practices which infrastructure are done. Let me tell you, here from Ahmedabad, the biggest model of sustainability is nothing but the Sabarmati Riverfront project. What it was before 2005, what it is after, I will say, 2014. There's a big difference. Otherwise, a river which Indians have converted into a nala, I don't feel ashamed to say this, but yes, all our Indian rivers have been converted thanks to our traditional, thanks to our practice, पूजे का सामान हम नदी में डाल के अपने आप को पवित्र समझ के, no, you have to come up with the, but here is an example, here a very wide bank of the Sabarmati river was actually shortened, or reduced, it was made deeper. In process of deepening, whatever the trace material we could collect, we have placed it as a reclamation. We have widened the working area around the Sabarmati river. Now this Sabarmati river front is a conclave of economic development, of social upliftment, of cultural development, of a beautification, of a tourist spot. You can name 1, 2, 3, 4, 5, 6, one after another. A riverfront model in India for other riverfront development like Yamuna and Ganga. We are late, but we have started. The show is on, the beginning is made, the world is watching. Sustainability, to be underlined, is not an organization, not a nation's responsibility, just to say, but a responsibility for each and every individual like us. At the end, let me congratulate once again for the World Engineering Innovation for More Resilient World Day. And I thank the organizer for giving a chance to share the opportunities of the experiences with the learner audience and the accomplished dignitaries which were in the dais. Thanks a lot.
Thank you so much, Dr. Basarkar, for enlightening us deeply on the subject. I shall now request Engineer D.O. Nagrani to present a memento to Honorable Dr. Sunil Basarkar.
Responsibility. I'll get back with the answers to your query. Thank you.
Moving on, we shall now invite our next speaker. As we all know, we are running short of time. I'll request our next speaker to be brief and wrap it up in say 15 minutes or so. We now invite Shri Ashish Pathak with 32 years of experience with diverse industries and technologies. 7 years as commercial techno in charge at Larsen & Toubro Cement Limited, having experience in construction chemicals, tiles industry, pipe and plumbing industry, and expert in ACC block concept, one of the kind in the whole country on pan-India and export market. And he has successfully launched the concept of white topping technology for roads on pan-India basis. And to speak on the stage, we invite Shri Ashish Pathak from Ultratech.
उपस्थित अतिथिगण तथा महानुभाव, मैं आपका हिंदी में ही स्वागत करूंगा क्योंकि मैं अपने जज्बात और अपने पैशन को यानी अपने को हिंदी में बेहतर बता सकता हूँ। मैं नौकरी नहीं करता, मैं जॉब नहीं करता, मैं जुनूनी आदमी हूँ। मैं अपने जुनून पे लगा रहता हूँ। वाइट टॉपिंग मेरा जुनून है। और एक दिन, क्योंकि अब ऐसे समय पर हूँ मैं जब 4 साल बाकी है और मेरा सत्र खत्म होता है, तो मेरा एक ही सपना है, मेरे हिंदुस्तान की रोड किसी भी मायने में दुनिया में किसी भी समृद्ध देश के रोडों से कम ना हो। इसी में सुबह शाम रात दिन हिंदुस्तान का भ्रमण करता रहता हूँ। तो वाइट टॉपिंग का मैं आपको यहाँ पे एक छोटा सा व्याख्यान दूंगा। वाइट टॉपिंग 2019 में मैंने ज्वाइन किया था और इस कंसेप्ट से मैं इतना प्रभावित हुआ कि अब जीवन की शैली बना ली है। तो वाइट टॉपिंग अगर हम देखें तो ये रोड कंस्ट्रक्शन नहीं है। बहुत सिंपल सी बात है, ये रोड कंस्ट्रक्शन नहीं है। ये एक तरीके का ओवरले है। ये रोड मेंटेनेंस का पार्ट है, जहां पर असफाल्ट के ऊपर हम वाइट टॉपिंग करते हैं एज अ इन प्लेस ऑफ री असफाल्टिंग, हम उसकी जगह पे वाइट टॉपिंग का लेयर करते हैं। तो बेसिकली अगर वाइट टॉप 15 मिनट है मेरे पास, सॉरी, तो अगर वाइट टॉपिंग कंसेप्ट देखा जाए तो दो ही तरीके हैं रोड बनाने के। एक ब्लैक टॉप है जिसको असफाल्ट कहते हैं, और एक सीमेंट वाला है, वो ऑफ वाइट होता है इसलिए उसको वाइट टॉपिंग कहते हैं। अब असफाल्ट वाला तो प्रोफेसर साहब ने बता दिया, धर्मवीर जी ने, और उससे बहुत ज्ञान वृद्धि हुई मेरी भी। सीमेंट वाला जो है इसमें 3 प्रकार आते हैं, मोटे मोटे 2 प्रकार है। एक जो सीसी रोड है जिसमें मैकेडम की जो साइज है, जो ब्रेथ है, वो 200 से 300 mm होती है, उसको हम कंक्रीट रोड कहते हैं या कन्वेंशनल रोड कहते हैं। अब बी पार्ट में आ जाते हैं। बी पार्ट में होती है थिन वाइट टॉपिंग और अल्ट्रा थिन वाइट टॉपिंग। ये मैं आपको इसलिए बहुत विशेषतः बता रहा हूं क्योंकि पूरे हिंदुस्तान में एक शब्द मशहूर है TWT, जो कि बिल्कुल ही जिसका कोई आधार नहीं है। TWT कुछ होता नहीं है। थिन वाइट टॉपिंग जो है वो तो अगर उसकी वो देखें, ब्रेथ देखें, तो 100 mm से लेके 200 mm का उसका मैकेडम होता है, उसको थिन वाइट टॉपिंग कहते हैं। और वही मैं प्रपोज कर रहा हूं, वही मैं प्रोपोगेट कर रहा हूं। अल्ट्रा थिन नहीं कर रहा। अल्ट्रा थिन 50 mm से लेके 100 mm तक होती है। ये हिंदुस्तान में इतनी यूज नहीं होती क्योंकि धन्यवाद है हमारे रोडों को यूज किया जाता है ओवरलोडिंग के लिए, इसलिए UTW हमारे यहाँ नहीं यूज हो सकती। तो ये बेसिक आधार है जो मैं आपको बताना चाहता था। दूसरा, जैसे साहब ने बताया, सीमेंट रोड में सीमेंट इज एज ए बाइंडर, वो 15% यूज होता है, और असफाल्ट रोड में असफाल्ट एज ए बाइंडर 5% यूज होता है। तो मोटा मोटा अगर समझे इसको, तो जैसे साहब ने बोला डिजाइनिंग मेरा सब्जेक्ट नहीं, क्योंकि हमारे डिजाइनिंग कंसल्टेंट्स करते हैं डिजाइनिंग। VDF यानी वेहिकुलर डिस्ट्रक्शन फैक्टर जो है वो असफाल्ट को ज्यादा प्रभावित करेगा, सीमेंट को कम करेगा, क्योंकि बाइंडर ज्यादा है। करेक्ट, सिंपल लॉजिक्स में। तो जिसकी वजह से इसकी लाइफ बढ़ जाती है। तो अभी हमें असफाल्ट रोड बहुत अच्छी चीज है, बहुत अच्छा, अगर उसको बनाया जाए, उसके साथ ड्रेनेज किया जाए तो बहुत अच्छा है। लेकिन असफाल्ट के अगर हम वाटर पर्कुलेशन को रोक दें तो पॉटहोल फॉर्मेशन नहीं होगा, तब असफाल्ट लंबा चल सकता है। लेकिन हम वाटर पर्कुलेशन को रोक इसलिए नहीं सकते क्योंकि VDF फैक्टर हाई है, गाड़ियां तो मूव करेंगी, हर एक गाड़ी से जो डिस्ट्रक्शन है वो ज्यादा हो रहा है कंपैरेटिवली। तो ये टेक्नोलॉजी एक बेसिकली एक ऐसी टेक्नोलॉजी है जो दोनों के बीच की टेक्नोलॉजी है, जिसको हम कह सकते हैं रिजिड कम फ्लेक्सिबल पेवमेंट। सही है सर? रिजिड कम फ्लेक्सिबल पेवमेंट, जिसमें असफाल्ट की अच्छाइयां जो है वो सीमेंट की बुराइयां को ढक लेती है, और सीमेंट की अच्छाइयां जो है वो असफाल्ट की बुराइयां को ढक लेती है। ये एक सिम्बायोटिक रिलेशन है इनके बीच में। तो ये, अब मैं इसके आगे शुरू करता हूं। नेक्स्ट, अभी गडकरी साहब जो है हर फोरम पे हमें ये टेक्नोलॉजी के बारे में मेरे से ज्यादा प्रोपोगेट करते हैं। और
India is all where you are seeing the pots work. But in 96-97, at that time we constructed Mumbai-Pune Express Highway. There is no single pot hole, because we have constructed from now this is from last 24 years, because it is in cement concrete. In Nagpur, whole Nagpur we are going to construct concrete road, so we don't have problem. So the Ultratech company, one of the technical person who is very capable, is now retired.
My boss.
He has that white topping technology. The 8-inch of white topping concrete on bitumen paste
highest limit
can be possible, and 1 to 2 inch bitumen surfacing, by which we can make the quality of the road exactly very comfortable. So by the new innovation and new research, you can reduce Idea is all where you are seeing the potswork. But in 96, 97, at that time,
अभी दिस इज बॉम्बे, साहब आप बॉम्बे से हैं, मैं भी बॉम्बे से हूँ, लेकिन बड़े अचरज की बात है, बॉम्बे से 20 किलोमीटर दूर एक जगह है जिसका नाम है थाने, वहां पे एक पॉटहोल नहीं होता, वहां की कभी कोई खबर नहीं आती। क्यों नहीं आती? एज इंजीनियर्स वी ऑल से क्यों नहीं आती, कब नहीं आती, कैसे नहीं आती? वो इसलिए नहीं आती क्योंकि 2008 से लेके आज तक वहां पे व्हाइट टॉपिंग का ही काम होता है। आप पूरे थाने में घूमेंगे, सिर्फ व्हाइट टॉपिंग के सिर्फ और कुछ नहीं मिलेगा, वहां पे एक पॉटहोल नहीं होता। तो इस वजह से अभी साहब ने बोला बहुत बड़ा एक्सचेकर खर्च होता है बॉम्बे में हर साल, बॉम्बे में, वो एक राजनीति का विषय है, उसके बारे में ज्यादा बात करें तो ना ज्यादा अच्छा नहीं होगा। तो ये पॉटहोल्स फॉर्मेशन होते हैं जिसकी वजह से जाम होते हैं। हिंदुस्तान में आज तक 11,000 लोग पॉटहोल से मर चुके हैं बरसात की वजह से। इतने आतंकवादी नहीं मार पाए जितना पॉटहोल्स ने मार दिया। नेक्स्ट, ये वही उसकी रिपोर्ट, ये हर साल, ये पीछे जाइए, ये बॉम्बे का नॉर्मल फीचर, पीछे पीछे पीछे, ये उधर वाली जो फोटोग्राफ है वो बॉम्बे की नॉर्मल फीचर है। ये वो कोल्ड मिक्स से हर साल रिपेयर किया जाता है और हर साल बाहर हो जाता है। ये देखिए हो रहा है, ये जरी आईआईटी के पास सबसे ज्यादा होता है सर, करेक्ट, ये हर साल होता है, कोई नई चीज नहीं है। नेक्स्ट, 11,000 लोग 4 साल में मरे हैं। नेक्स्ट, अब रटिंग एक ऐसा सब्जेक्ट है जो साहब ने बताया, उसके बहुत सारे कारण हैं। टेम्परेचर डिफरेंशियल है, हमारा देश ऐसा है जहाँ पे 50 डिग्री का टेम्परेचर डिफरेंशियल होता है। गर्मी में 50 डिग्री उत्तर भारत में चले जाए तो गर्मी में 50 के ऊपर भी चला जाता है और सर्दी में 0 भी हो जाता है। तो रटिंग होना स्वाभाविक है। तो हमें, जैसे यहाँ पर मैं हमेशा कहता हूँ, इंजीनियरिंग सब्जेक्ट नहीं है, इट इज ओनली एंड ओनली इनोवेशंस। आउट ऑफ द फॉर्मेट की आर्टिस्टिक थिंकिंग को आप प्रैक्टिकलिटी में लाते हैं इंजीनियरिंग के थ्रू। ये जो बीच के सिद्धांत है रहते हैं, लेकिन ये सिद्धांत इनोवेशन के द्वारा जब कार्यान्वित होते हैं तब वो सपने जो है वो साकार होते हैं। तो सर ये इनोवेशन है, ये इंजीनियरिंग नहीं है, मेरा ऐसा मानने का। क्योंकि हमेशा ऐसा कहते हैं कि साहब इंस्टीट्यूट जो है वो प्रिंसिपल्स फॉलो नहीं होते हैं सिविल इंजीनियरिंग के। क्यों नहीं होते? क्योंकि वो इनोवेशन है, वो सिद्धांत थंब रूल है, वहां से शुरू करते हैं फिर उसके बाद इनोवेशंस लगाते हैं। करेक्ट? तो ये बेसिकली ये प्रॉब्लम शुरू हुई थी, ये हिंदुस्तान असफाल्ट की रोड बननी शुरू क्यों हुई, इसका छोटा सा आपको इतिहास बता दूं। द्वितीय विश्व युद्ध के बाद सभी इकोनॉमी शटर हो चुकी थी, तो ये हुआ कि भाई कैसे रिवाइव करेंगे। तो रिवाइव करने के लिए कंजम्पशन बढ़ाइए, कंजम्पशन बढ़ाने के लिए प्रोडक्शन बढ़ाइए, प्रोडक्शन बढ़ाने के लिए एनर्जी चाहिए। एनर्जी कहाँ से मिलेगी? नया नया पेट्रोल मिला है, इसको पेट्रोलियम प्रोडक्ट्स को यूज कर लो। सेकेंड वर्ल्ड वॉर के बाद ज्यादा पेट्रोलियम यूज हुआ, तो उसमें जो 53 बाय प्रोडक्ट्स निकलते हैं उसमें असफाल्ट एक ऐसा प्रोडक्ट है जिसका कोई यूसेज नहीं है अदर देन उसको बोला रोड में डाल दो यार, जो प्रोडक्शन होगा कम से कम मार्केट तक तो भेज देंगे। तो उसके लिए असफाल्ट यूज होने लगा। लेकिन हमसे पहले यूरोपियन और वेस्टर्न इकोनॉमीज ने इस चीज को पहचान लिया था कि ये ऑल वेदर मटेरियल नहीं है, ये गर्मी में पिघल जाता है और सर्दियों में सिकुड़ जाता है, तो इसलिए ऑल वेदर प्रोडक्ट नहीं है। तो उन्होंने 1960 से व्हाइट टॉपिंग स्टार्ट शुरू कर दी थी अपने एरिया में। हमारे यहाँ पहुंचते पहुंचते में थोड़ा टाइम लग गया, लेकिन आ गए। देर है दुरुस्त है, करेक्ट सर? तो ये प्रॉब्लम व्हाइट टॉपिंग वहां पे अमेरिका में सबसे पहले देखी गई थी। फिर उन्होंने सोचा कि व्हाइट क्यों ना एग्जिस्टिंग असफाल्ट को ही, जैसे साहब बता रहे थे, एग्जिस्टिंग चीजों को ही रीयूज कर ले, ना कि कुछ उसको उखाड़ के सब कुछ नया बनाए। तो उसी के लिए, उसी के आधार पे ये नॉलेज का को डिस्कवर किया गया, इजाद की गई। नेक्स्ट, ये फ्लेक्सिबल पेमेंट में बेसिकली क्योंकि ये फ्लेक्सिबल इन नेचर है तो इसलिए, और जैसे मैंने बताया ये फ्लेक्स लोड आने पर फ्लेक्स करता है, जिसकी वजह से इसमें क्रैक्स डेवलप होते हैं या जिसकी पोरोसिटी भी रहती है। तो ये बेसिकली डीबॉन्डिंग, जिसकी वजह से पानी जब नीचे जाता है तो वो जो ग्रिट है, ग्रिट के साथ जो असफाल्ट है उसके गैप में भी पानी जाता है और कुछ समय बाद वो ग्रिट छोड़ देता है असफाल्ट को और इस तरीके से डीबॉन्डिंग हो जाती है। तो वाटर पर्कुलेशन रोकना एक बेहद जरूरी चीज हो जाता है, जो कि बीसी से कोशिश करते हैं लेकिन 100% शायद नहीं हो पाता। नेक्स्ट, हमारे हिंदुस्तान में कुछ 78 लाख किलोमीटर रोड है आज के दिन में, और जैसे साहब ने बताया हम दूसरे स्थान रखते हैं विश्व में हमारे पास मोटरेबल रोड्स होने का। बहुत जल्दी हम पहला भी रखेंगे, लेकिन तो इसलिए हमारे पास एग्जिस्टिंग बिटुमेन रोड्स है जिसको हम कम खर्चे से सीमेंट रोड में परिवर्तित कर सकते हैं, जिससे कि उसकी लाइफ स्पान तो सेम है जैसे सीसी रोड है। डिजाइन लाइफ 20 इयर्स है, वी से 30 इयर्स, गडकरी साहब 50 साल बोलते हैं। सीसी रोड की भी ऑलमोस्ट वही है, लेकिन कॉस्टिंग में वो कम है क्योंकि वहां पे मैकेडम जो है वो 200 to 300 mm के बीच में है और यहाँ पे 100 to 200 के बीच में है। तो अप्रोक्सीमेटली एवरेज लेंगे तो 40% की सेविंग हो जाती है, करेक्ट। तो हम अगर एग्जिस्टिंग बिटुमेन रोड को ही कन्वर्ट कर देते हैं तो हमारी खर्चा कम आएगा और हमें उसकी लंबे समय तक इकोनॉमीज मिलेंगी। राइडेबल यानी कि गाड़ी ड्राइव करने का कंफर्ट की कोई न्यूमेरिक वैल्यू नहीं होती है, वो तो हम साइड में करते हैं, वो बोनस है। लेकिन उसके अलावा आपको पॉटहोल्स नहीं मिलेंगे। दूसरा, इसके अंदर आपको हर चौथे, पांचवें या 8वें साल रीअसफाल्टिंग जैसी चीज कुछ नहीं करनी पड़ेगी। 30 साल तक एज इट इज रहेगा, 30 साल से भी ज्यादा रहेगा। आपको एक लाइव एग्जांपल बता दें, आप सब लोग एक रोड पे गए हुए जिसका नाम है मरीन ड्राइव, क्वींस नेकलेस, करेक्ट। 1939 में बनाई थी अंग्रेजों ने 33 ग्रेड सीमेंट से। अगेन बॉम्बे भर में पॉट होल्स होते, वहां पॉट होल नहीं होते। 81 इयर्स हो गए, माइनर रिपेयरिंग हुई है सर उसके ऊपर। सोचिए कितना पैसा सरकार ने बचा लिया। ये पैसा और दूसरे प्रोजेक्ट्स में यूज होगा। ये समझने वाला पॉइंट है। पैसा खर्च करने के लिए नहीं होता है, पैसा बुद्धि के साथ खर्च करने के लिए होता है। अरे मैं गलत करता तो गुजरातियों को बता रहा हूं, ये तो मुझसे बेहतर जानते हैं। नेक्स्ट, सर्विसिबिलिटी इसलिए बेहतर है क्योंकि इसमें रैपिड लॉस होता है, बिटुमेन में इसमें लॉस नहीं होता। और इसमें कंक्रीट, हाँ इसमें दूसरी चीज है, 2-3 चीजें हैं इसमें। ये रोड जो हम बनाते हैं थिन वाइट टॉपिंग, ये एज पर IRC SP 76 2015 अपडेटेड के हिसाब से बनाते हैं, के आधार पे बनाते हैं। और दूसरा, प्रैक्टिकलिटी को भी बहुत ध्यान में रखते हैं। इसमें समझने वाला पॉइंट है बचत क्यों होती है। आप जब सीमेंट, जब पैनल साइज हम छोटी कर देते हैं, यहाँ पे पैनल साइज 1 मीटर बाई 1 मीटर की हम रखते हैं, उसकी वजह से जो ब्रेथ है पेवमेंट की वो रिड्यूस हो जाती है, क्योंकि कर्लिंग बेंडिंग स्ट्रेसेस जो है ड्यू टू टेम्परेचर और ड्यू टू लोड, उसको बियर करने के लिए आप मोटा मैकेडम रखते हैं। यहाँ पे हमने पैनल साइज जब छोटी कर दी तो उसमें इक्वलाइजेशन ऑफ टेम्परेचर फास्ट हुआ, क्योंकि जो कॉन्ट्रैक्शन जॉइंट है उसके अंदर एयर सर्कुलेट करती है फर्स्ट ऑफ ऑल। दूसरा कि एक पैनल पे 2 व्हील्स कभी नहीं हो सकते, इसलिए हम इसको छोटा कर सकते हैं। ये छोटा करने में, उसकी ब्रेथ छोटा करने में हमारी सेविंग हो जाती है, करेक्ट। तो दूसरा, इसमें जो मेन पॉइंट है वो ये है समझने वाला है कि थिन वाइट टॉपिंग में जैसे एग्जांपल हम लोगों ने कोई ऐसे स्थान पे बनाई जहां पर पानी का इनंडेशन बहुत होता है या वाटर रेनफॉल बहुत होता है, जैसे कि बेंगलोर की नाइस रोड है, आप लोग सब गए होंगे, नाइस रोड, आउटर रिंग रोड जो नाइस रोड कहलाती है, वो 2012 में हमने प्रोपेगेट किया था कंसेप्ट। हमारे बॉस है जिनके बारे में गडकरी जी बोल रहे थे, और 2012 में बनाई थी। वो रोड पे हर 1 साल बाद असफाल्टिंग होती थी, क्योंकि पानी एक समय 6 महीने तक लगभग बेंगलोर में हर दिन 4 बजे गिरता है, और वो पेड़ों से जो ड्रिपिंग होती थी वो असफाल्ट को कोरल फॉर्मेशन दे देती थी। तो ये टेक्नोलॉजी 2012 से हम लोगों ने उसकी रोड बनाई, आज 2023 हो गया है, उसके ऊपर कोई रिपेयर नहीं हुआ है। सोचिए बेंगलोर सरकार, बेंगलोर म्यूनिसिपल कॉर्पोरेशन ने कितना पैसा बचा लिया। अब वो पैसे की बचत से मैसूर तक की रोड बन रही है सेम टेक्नोलॉजी से। तो कॉस्ट इफेक्टिव है बताने का एक तरीका था कि आपको ये कैसे कॉस्ट इफेक्टिव है और क्यों है। इनिशियल कॉस्ट पहले ज्यादा थी, यूक्रेन वॉर को सारा श्रेय जाता है कि उसने बिटुमेन को महंगा कर दिया, तो इसलिए आज वो डिफरेंस रह नहीं गया। अभी मध्य प्रदेश में भोपाल में किसी से डिस्कस कर रहा था तो उन्होंने बोला रीएस्फाल्टिंग में साहब हमारा 1.5 करोड़ रुपीस पर किलोमीटर 2 लेन का खर्चा होता है। तो हमने कहा साहब हम तो आपको 2 लेन बना के दे रहे हैं, 30 साल तक इंश्योरेंस दे रहे हैं, 1.62 करोड़ है, मार्जिनल है, तो आपको उसमें बेनिफिट्स कितने मिल रहे हैं, आपका पैसा कितना सेव हो रहा है। फिर एनवायरमेंटल फ्रेंडली, क्योंकि सस्टेनेबल आज का शब्द है, हिंदुस्तान के लिए सस्टेनेबिलिटी कोई नई चीज नहीं है। ये गोरों ने आके हमें समझा दिया कि सस्टेनेबिलिटी, हम तो जमाने से सस्टेनेबल थे और है और रहेंगे, क्योंकि हम कंज्यूमरिज्म में बिलीव नहीं करते, हम चीजें यूज करके फेंकते नहीं है। एनीवे, तो सस्टेनेबिलिटी इसलिए है क्योंकि इसमें हम फ्लाई ऐश यूज करते हैं जी, सिलिका फ्यूम्स यूज करते हैं, इसके अंदर हम फ्लाई ऐश यूज करते हैं, जिसकी वजह से कार्बन रेटिंग में इसके 61 पॉइंट्स है और असफाल्ट के 30 है, 70 इज एब्सोल्युटली ग्रीन। तो ये कहना कि हम पूरे ग्रीन है ऐसा नहीं, लेकिन ग्रीन के बहुत करीब है, यानी हल्के ग्रीन है बेसिकली। नेक्स्ट, आईआरसी के बारे में बता दिया, अभी टेक्निकल बात थोड़ी कर ले तो बेहतर रहेगा। नेक्स्ट, ये एक प्रोसेस है जिसमें हम वाइट टॉपिंग एज पर आईआरसी करते हैं, जिसमें एग्जिस्टिंग असफाल्ट लेयर की हम पहले मिलिंग कर लेते हैं टू मेक इट अ सीमलेस सरफेस। सीमलेस सरफेस के बाद उसके बाद हम उसकी कंप्रेस जेट से उसको सफाई कर लेते हैं, वो रफ हो जाती है सरफेस, और वो जो लास्ट में आप देख रहे हैं वो रफ हो गई, रटिंग है जितनी थी इसको हटा के हमने लास्ट में लेफ्ट साइड लास्ट में हमने उसकी सफाई कर ली, और फिर उसके बाद उसके ऊपर M40 ग्रेड का मिनिमम कंक्रीट, M40 इज द मिनिमम कंक्रीट ग्रेड विच कैन बी यूज्ड फॉर वाइट टॉपिंग, उससे नीचे का नहीं यूज करने का, क्योंकि आईआरसी में ऐसा निर्धारित किया गया है। तो उसके बाद हम उसका कंपैक्शन करते हैं। कंपैक्शन अगेन, बहुत सारी चीजें ऐसी हैं जो बहुत गलतियां करते हैं रोड बनाने में। पहले तो कंपैक्शन करने के बाद जो हम अपना नीडल वाइब्रेटर यूज करते हैं, उसके एंगल्स का हमें कोई खबर नहीं होता। उसके एंगल्स 65 डिग्री पे होने चाहिए तो हम 90 डिग्री पे कर देते हैं। तो 90 डिग्री पे अब क्या होता है 90 डिग्री पे सीमेंट और पानी की स्लरी ऊपर आ जाती है और हैवी पार्टिकल्स बैठ जाते हैं। तो उसके बाद 2-3 साल बाद हमारे ऊपर इल्जाम लगता है कि साहब आपकी सीमेंट की रोड जो बनी उसके अंदर जो मेटल है वो तो बाहर दिखने लगा, उसकी अपर सरफेस हट गई। अरे भाई, ये कंक्रीट है, किसी को माफ नहीं करेगी। अगर आपने सिद्धांतों को फॉलो नहीं किया, बिल्कुल माफी की कोई गुंजाइश नहीं है, आधा घंटे की कोई गुंजाइश नहीं, क्रैक्स आ जाएंगे। साहब ने दिखाए, जैसे क्रैक्स दिखाए थे, तो क्रैक्स के 2 तरीके हैं, या तो वो लॉन्गिट्यूडनल होते हैं या वो ट्रांसवर्स होते हैं। करेक्ट, मोटे मोटे तौर पे डायगोनल बहुत कम होते हैं, बट होते हैं। ट्रांसवर्स जब होते हैं तो इसका मतलब बेसिकली जो हम लोग समझते हैं वो ये है, ये श्रिंकेज क्रैक्स हैं, समय पर इसकी ग्रूविंग नहीं की गई। पहला लॉन्गिट्यूडनल, जैसे साहब ने दिखाया, मैं एक बार रायपुर से बिलासपुर जा रहा था, 15 किलोमीटर के लॉन्गिट्यूडनल क्रैक्स है। ये एक स्ट्रक्चरल फॉल्ट है जो रोड बनाने से पहले नहीं देखी गई कि स्टेटा सेटलमेंट में डिफरेंशियल है। उसके लिए आपको सर्वप्रथम सीटीबी करना पड़ेगा, 4% सीमेंट के साथ मिला के, सबसे सस्ता और टिकाऊ तरीका है। 4% सीमेंट मिला के उसको आप पल्वराइज करके फिर से कंपैक्ट करके उसको कर दीजिए। नासिक साहब ने जो फोटो दिखाई थी वो नासिक की मैक्सिमम थी, इगतपुरी टू पिंपल गांव, करेक्ट। वो वर्टगन वहाँ पे यूज हुआ था। उन्होंने 2019 में हाँ मैं 15 में ध्यान दे रहा हूँ, 15 मिनट में ध्यान दे रहा हूँ, बिल्कुल बिल्कुल 15 मिनट में ध्यान दे रहा हूँ। नेक्स्ट, पूरा मेरा ध्यान है। नेक्स्ट, इसके एडवांटेजेस क्या है? 20 से 25 साल है। दूसरा, अगर आप शहरी में क्षेत्रों में यूज करते हैं तो ये वाइट टॉपिंग है, तो इस वजह से क्या है कि इसका रिफ्लेक्शन हाई होता है। रिफ्लेक्शन हाई होने से एक्सीडेंट्स कम होते हैं रात में, क्योंकि ऑब्जेक्ट क्लियर दिखता है पहला। दूसरा, पर किलोमीटर अगर आपको 10 पोल्स लगाने हैं तो यहाँ पे 7 पोल लगाने पड़ते हैं, तो आपके कैपिटल एक्सपेंडिचर कम होता है, केपेक्स कम होती है। तीसरा, पर पोल इल्यूमिनेशन 250 वॉट की जगह 150 कर सकते हैं, तो आपके रिकरिंग एक्सपेंसेस कम हो गए। नेक्स्ट, ये पॉइंट समझिएगा, पॉटहोल फॉर्मेशन क्यों होते हैं? क्योंकि फ्लेक्सिबल नेचर होता है असफाल्ट का, इसलिए वो देखिए लोड डिस्ट्रीब्यूशन इज इन यू फॉर्म और ऑलमोस्ट वी फॉर्म। जो उसका बेस है वो वीक हो जाता है, और ऊपर से जब पानी बरसता है तो वो एक जख्म पे नमक का काम करता है और वो जगह बैठ जाती है जो यू पॉइंट नीचे का है, और ऊपर से रिफ्लेक्टिव क्रैक पॉटहोल आ जाता है, जिसको हम पॉटहोल बोलते हैं। ये सीमेंट में क्योंकि वाटर हमने बिल्कुल नील कर दिया है, क्योंकि हम जो कंक्रीट यूज करते हैं उसके अंदर वाटर सीमेंट रेशियो 0.3 के नीचे का होता है, और उसमें भी सुपर प्लास्टिसाइजर्स हम यूज करते हैं, तो कैपिलरी ब्लॉक होती है, इसकी वजह से वाटर पर्कुलेशन नहीं होता, और लोड डिस्ट्रीब्यूशन इज इन डी फॉर्म, कैपिटल डी फॉर्म, जिसकी वजह से वो वीक नहीं होता सब बेस, और उसमें पॉटहोल फॉर्मेशन नहीं होता। नेक्स्ट, ये मैंने बताया आपको। नेक्स्ट, ये बहुत हमारे ऊपर अगेन इल्जाम लगता है कि साहब आपकी सड़क गर्म हो जाती है ज्यादा। बेसिक इंजीनियरिंग का सिद्धांत है, सफेद सरफेस कभी गर्म नहीं होती, काली सरफेस गर्म ज्यादा होती है। ये महालक्ष्मी में किया हुआ एक टेस्ट है, आप देख लीजिए 7 डिग्री फ़ारेनहाइट का फर्क है। नेक्स्ट, ये इसके प्रोसेस है जो मैंने आपको बता दिए। हाँ, 2-3 चीजें इसमें। नेक्स्ट, मिलिंग ये हो रही है, मैंने बताया पहला पॉइंट मिलिंग है। सेकंड, ये क्लियर कर लिया हमने एयर ब्लोअर से। थर्ड, फिर उसके बाद हमने ये अपना फिक्स फॉर्म पेवर है, ये स्लिप फॉर्म पेवर है, इसमें बड़ी रोड के लिए यूज होता है, इतना बताऊंगा नहीं, उन्हें डिटेल प्रॉब्लम हो जाएगी। नेक्स्ट, ये इसके बाद ये बहुत जरूरी है करना, क्योंकि इसमें क्या डी वाटरिंग नहीं होती है। इसको बुल फ्लोट बोलते हैं। बुल फ्लोट से ट्रोवलिंग करते हैं, एक तरीके की ट्रोवलिंग है ये, और उसके बाद इसको छोड़ दिया जाता है। तो उसके बाद उसके ऊपर जब ऊपर की सरफेस की शीन खत्म हो जाए पानी की, तब उसके ऊपर हमको चमक खत्म हो जाए, तब हमें उसके ऊपर टेक्सचरिंग करनी होती है। टेक्सचरिंग हमेशा ट्रांसीडेंटल होनी चाहिए। टेक्सचरिंग शुड नॉट बी लॉन्गिट्यूडनल। अभी आई वाज इन गोरखपुर, लखनऊ से गोरखपुर जा रहा था, बड़ा अच्छा एग्जाम्पल है साहब। 100 किलोमीटर लॉन्गिट्यूडनल टेक्सचरिंग है। फिर उसके बाद हमारे ऊपर इल्जाम लगता है कि साहब आपकी रोड आवाज बहुत करती है। मैंने अब जैसे बताया, मैं शुरुआत मैंने टायर से की थी, तो टायर जब चलता है तो उसके ये ट्रेड्स होते हैं, बीच में गैप होता है, ये एयर एस्केप करती है, टायर को ठंडा रखती है। तो जब टायर चलता है तो यहां से भी एयर भागती है, तो ये टेक्सचरिंग जो हम बनाते हैं उससे एयर एस्केप करती है, आवाज नहीं होती है। अगर ये टेक्सचरिंग घिस जाएगी तो आवाज करने लगेगी। नेक्स्ट, ये क्योरिंग कंपाउंड हम स्प्रे करते हैं। अब आप लोग सब क्योरिंग कंपाउंड आप लोगों ने डाल ही नहीं रखा अपने एसओआर में, बड़े आश्चर्य की बात है। क्योरिंग कंपाउंड डालना इज मस्ट, क्योंकि ये सरफेस, एक्सपोज सरफेस का जो प्रोपोर्शन है विद द ब्रेथ ऑफ द मैकेडम वो नेगेटिव है, दैट लीड्स टू हाइपर इवेपोरेशन। जब पानी निकल जाएगा तो कहां से आप उसके रिएक्शन नहीं होगा, तो सॉलिडिफाई नहीं होगा, तो इसलिए हमें उसके ऊपर क्योरिंग कंपाउंड डालना पड़ता है। वैक्स बेस्ड, मिनरल बेस्ड नहीं, वैक्स बेस्ड, व्हाइट इन कलर। तो उसके बाद इसके ऊपर एशियन क्लॉथ होता है। ये एक चीज हमेशा याद रख लीजिए आप लोग, जनरल मिस्टेक है राउंड द कंट्री, जम्मू कश्मीर से केरल तक और उधर सिक्किम से लेके कांडला तक 18 घंटे से और 36 घंटे में ग्रूविंग करते हैं, 3 दिन बाद ग्रूविंग करते हैं। आपको मालूम है सीमेंट की परमिसिबल लिमिट हीट ऑफ हाइड्रेशन की 60 जूल्स पर ग्राम, लेकिन क्योंकि कंक्रीट M40 ग्रेड का है, तो इसलिए ये पहुंच जाता है 150 जूल्स पर ग्राम, तो श्रिंकेज क्रैक्स तो आएंगे ही ना फिर। इसलिए अब कब करना चाहिए? उसको करना चाहिए जब आपका लेमैन की लैंग्वेज है, जब थंब इंप्रेशन आ जाए, पैर रखे और इंप्रेशन नहीं जाए, तो आप उसमें ग्रूविंग स्टार्ट कर दें। ग्रूविंग शुड बी 1/3 द डेप्थ ऑफ द मैकेडम। 6 इंच का है तो ये 2 इंच ही करना है, पूरा नहीं करना, पहला। दूसरा, अब टेक्निकल बात कर ले। इसमें टेक्निकल विंडो जो है एज पर IRC 83, उसके हिसाब से टेक्निकल विंडो जो है वो जब कंक्रीट की स्ट्रेंथ 2 न्यूटन पर मिलीमीटर स्क्वायर अटेन हो जाए और 7 न्यूटन पर मिलीमीटर स्क्वायर से पहले इसके, यानी 5 न्यूटन की विंडो है, इसके बीच में हो जाना चाहिए। लेकिन हमारे वहां करते हैं 18 से 36 घंटे के बाद, तो क्रैक्स आएंगी ना फिर। तो बेसिकली ये आई थिंक 15 मिनट्स ओवर, करेक्ट। तो इसके अलावा आप कोई क्वेश्चन, इसके ऊपर हेसिंग क्लॉथ डालना चाहिए जो कि वेट रहना चाहिए। वाटर बनाने की कोई जरूरत नहीं, पानी भरने की कोई जरूरत नहीं है। बता दो, मैं तो कल तक बात कर सकता हूँ, लेकिन समय में हमें लामबंद कर दिया है साहब ने, तो हम इसलिए इतना ही बोल सकते हैं। धन्यवाद, आप सबका बहुत बहुत धन्यवाद। और प्रश्न, अगर आपको कोई प्रश्न पूछना है तो आप आमंत्रित हैं, क्योंकि आपका हर एक प्रश्न हमारे लिए एक नया बिजनेस होता है, क्योंकि आपकी प्रॉब्लम हमारी बिजनेस है। कोई सवाल इस विषय में? एनी क्वेश्चन? भूख ज्यादा लगी शायद। जी
समझ में आ गया, इसीलिए कोई क्वेश्चन नहीं।
सर, माने 2 ही होते हैं, या तो समझ में पूरा आ गया या समझ में कुछ नहीं आया। थैंक यू वेरी मच। और इतनी सहनशील ऑडियंस के लिए मैं एक बार फिर से धन्यवाद देता हूँ अल्ट्राटेक की तरफ से। आप सबको बहुत बहुत, आप सबका धन्यवाद।
बहुत बहुत धन्यवाद मिस्टर पाठक। सस्टेनेबल रोड सॉल्यूशंस के रूप में वाइट टॉपिक टेक्नोलॉजी के बेहतरीन इनोवेशन को, इसकी बहुत सारी बेहतरीन जानकारी हमसे साझा करने के लिए मैं अनुरोध करूंगी इंजीनियर हेमंत सुथार कमेटी मेंबर से मोमेंटो अर्पण करके पाठक जी का अभिनंदन करें। और एक बार फिर से हम बहुत बहुत तालियों से उनका अभिवादन कर लें। Thank you so much. And now I would like to invite Shri Harsh Patel, Product Manager from Kevitec Marketing Private Limited, to talk on building automation in sustainable development. And I would like to request to kindly please be very brief as we are overrunning these sessions. Thank you.
Hello. So, hello everyone. So, good afternoon. So, I will brief about the building automations very shortly. So, myself, Harsh Patel, and I am into the industry since last 8 years for the automation industry. So, today I am presenting the building automations in a sustainable development. So, where we can save the energy and where we can save the cost, right? So each and every time we know that can technology be useful to optimize the speed of the construction. So before the construction and during the construction we can save the lots of things, right? So nice. So is it possible to build the sustainability using the automation during the post construction? Because see, so next. During the constructions, we are facing the lots of problems like the coordinations between architect, consultant, and the on-field engineers, customers as well, rework, duplicate the work, and the waste of time and resources. Then we can use next. So with the AI, artificial intelligence, we can achieve the site progress. So after the 10 years or 5 years, if there is a leakage into the pipe or there is a issue in the particular area, so we can easily identify the issues with we can see the progress remotely as well. Then less rework and the better collaborations and the time faulty जो finding है, time fault finding है ना, तो easily कर सकते हैं, right? Next. So there is a very quick video. Can you please play? So during the construction, just the site engineer have to wear this camera, and all the things are captured in the camera. So okay, after the construction, we can easily identify the problem and we can solve the problem very easily. So where optimize can be done? So from the basement, from the parking area, passage area, staircase, washroom, we are wasting lots of energy, right? So how we can save the energy on these particular zones, particular areas? Next, in a parking, as we all know that we are entering into the basements not more than 3 to 4 times in a day, right? And we are wasting up to 95% energy. So what we can help next? So we can use the number of sensors, lighting sensors, right, for the lighting management solution. So if we are using the sensors, motion sensor and occupancy sensors into the basement area, so we can save the energy up to the 95%, right? Then we can also save the energy into the cabin areas or the conference room halls, banquet halls, right? Because most of the energy consumption into the HVAC, AC, right? So how we can save the energy into the HVAC? Can you go back? This is all about the smart sensors, occupancy sensors. So once we enter the particular premises, light and AC will be on, and there is no any occupancy, light and AC will be off. Here you can see in the passage areas, so if we are using the tube lights or any LED lights, right? So if we are using the without the motion sensors, the power capacity of 50 watt, and with the motion sensor 50 watt. If using hours is 12 hours, with the motion sensor using hour is 3 hours, right? So total consumption around 600 watt, and with the motion sensor 150 watt, right? So we are the particular total cost is without the motion sensor 108 rupees, right? And with the motion sensor 27 rupees. There is a huge difference between the energy cost. So we are saving the lots of energy. So if we are using the sensors, so this is called the lighting management solutions. So we can use this kind of technology into the building, and we'll save the cost and we'll save the energy as well. Next. So can lighting automations bring the sustainability into the building? Yes, definitely. Because what is automation? So in the lighting automations, we can dim the light and tune the light, right? Next. So as per the circadian lighting, it's a human-centric lighting. As per the sun movement from the 5 AM to 5 PM, there is a different color change, right? So yellowish to whole white, and then the yellowish, right? So it also depends upon impact upon the body health. It also helps us to reduce the cancers and skin disease as well. So as per the sun movement, it will also change the inside the scenario, the lighting temperature and the intensity. Can you play the video? There is no window or there is no any sunlight, so we can use this kind of technology and we get this kind of the luminosity into the particular frequency. So it will also help to increase the work efficiency as well, and even also helpful for our health as well. So now it's all about the automation. So we all are thinking about automation is a luxury. So it's totally wrong. So automation is a necessity in current era, right? Next. So for any conference room or banquet hall or this kind of the auditorium hall, we can use integrate the number of things into the single platform. Like here is a curtain, here the HVAC, the fan and lighting. So we have to operate with the different number of functions, number of different switches. With the automation, we know through the single click, we can integrate the scenarios. If there is a meeting scenario, if there is a presentation scenario, so all the lights are automatically dim. The curtain will be closed automatically, right? The AC temperature will be at certain temperature. So within a single click, we can create a scenarios. So that's how the automations helps, right? So how to operate a building sustainably? So having everything in a central place, so we can integrate everything like all the automations, LMS system and the security system into the central plate, and we can easily monitoring from the single platform and single area, right? Nice. So we can easily integrate all the things we are using already, like fire alarm system, public alarm system, CCTV camera, intrusion system, public announcement system, right? Building management system, energy meter, network monitoring, custom. So it's a camera. Next. So AI based video analytics we can easily integrate. So next. So can you play? I think we have sort of time, that's why I explained it very quickly. So if anyone have any doubt or any query, so we can discuss over a lunch time. So thank you so much for your time.
Thank you, Mr. Harsh, for enlightening us on the smart use of lighting by automation and in turn leading to sustainable development. I'd like to request Mr. Chirag Patel, Committee Member, IEI GSC, to felicitate Mr. Harsh by presenting a memento. So we once again thank all our keynote speakers and presenters, and now concluding, I would like to request Engineer D.O. Nakrani, Honorary Secretary, IEI, to present a vote of thanks.
On behalf of Institute of Engineers, Gujarat State Center and Staff Training College, Board of Gujarat, I am D.O. Nakrani, Honorary Secretary. Thanks for the opportunity to give vote of thanks on the auspicious day of World Aging. I am very much thankful to Sri Sandeep Basar sir, Secretary and our Council Member, past President and President of Indian Road Congress for his presence and his valuable words of importance of engineering and technology and our PM vision for the day. I am also thankful to Dr. G.J. Joshi sir, Head of Civil Engineering Department, for being our guest of honor and spare valuable time. We are thankful to him for his words about the environment aspect as well as the vision of our India 2030 for the environment and sustainable development in which the India is very much keen. So we are thankful, sir. I am also thankful to our past chairman, Sri H.U. Kalyani sahib, for his presence, and we congratulate him for his elect as the chairman of Board of Governors of Water Management Forum, and we are thankful for his motivation and blessing as our senior council member. Thank you. A special to Dr. Dharamveer Singh for his effective, easy to understand, and by his good example, practical photographs, and with research-based facts and figures, which is helpful to our engineers to understand the concept, how can we apply our knowledge in the sustainable development in our practices.
Thank you very much, sir. I am thankful to Dr. Sunil Basarkar, sir, for delivering the speech about the infrastructure sustainability. He has given very good example of the tunnel. It's a prestigious project of India by showing pictures, photographs, which is easy to understand, and how the infrastructure play an important role, and it is necessary to have a sustainability in the development of the infrastructure. Thank you, sir. I am thankful to Ashish Pathak for his effective presentation on the product. He has done very much important thing that it is important to have a product implementation properly. So, sir, thank you very much, and thankful to Harsh, who has presented very much effective present in a short time. But I think it will be useful all of us to go for the automation for the development of the sustainability. And last, I am thankful to Chief Engineer Director Sanghvi Sahib and Joint Director Sri Mehta Sahib for giving us opportunity to arrange such seminar in right place. I hope we will arrange more such program in future, and we will have a cooperation to each other. I thank to team of PIU, especially Gajjar Sahib, Nishit and his team members for their hard work for the arrangement. I thank to all our committee members, fellow members, students, engineers for being present in the seminar and making it successful at last. Without them, it is not possible to arrange this seminar. And thanks to all our engineers who is doing hard work in building our nation. I request all engineers to be a member of Institute of Engineers, which become a part of the global platform for the large family of engineers, technocrats, and academicians, research and scientists. Thank you very much. Now we go for the lunch and we end this session over here. Thank you very much.
Thank you so much, one and all, once again. And now, much awaited lunch is waiting for you. So let's all join together for the lunch. Thank you. But before we part, I would request all the dignitaries to please stay for a group photograph. We'll have a group photograph with the dignitaries and then join for the lunch. So dignitaries, please be here. Thank you.
Sir, फोटो तस्वीर